Ladies and gentlemen, please take your seats. The conference is about to start. Dear guests, we would like to kindly ask you to take your seats in the middle of the conference area to be able to take lovely pictures of you. Please take your seats as the conference is about to start. Good morning, Your Excellencies, ladies and gentlemen, participants, and dear guests. It's Fatma Fahad again. I hope you had a lovely evening last night and enjoyed some of the Saudi food served at the gala dinner. That was a lovely place to visit. Yeah, absolutely. It deserves a round of applause. I'm glad you enjoyed that. Yesterday, we had a fruitful and exciting morning and afternoon talking about everything policy and governance. We heard inspiring motivational opening remarks from the governor of CST, His Excellency At-Tamimi. And we heard also from the Secretary General of ITU, Ms. Doreen. And we heard also from the Director of UNOOSA, Ms. Arti. And that was also followed by an exciting keynote addresses and discussion panels touching about different industry topics from industry leaders from around the world, discussing topics from space debris mitigation to sustainable space future, to even providing invaluable insight into the challenges of the ever-growing issue of space debris. We also had representatives from UNOOSA discussing translating policy into progress. And we even talked about shaping the regulatory landscape and fostering responsible space activities. Now, the future of space governance was an important keynote address as well. That was followed by our last panel from yesterday, stressing on the importance of future regulations and guidelines. Today, however, ladies and gentlemen, we have an even more exciting agenda that will start by taking us on a mission to remove debris from Earth's orbit. So please, Mr. Luc Biguet, take us with you on that mission. The CEO of Clear Space, ladies and gentlemen.
Thank you for the invitation. It's been a real blast to be here, and I'm really happy to be part of the most exciting part of the conference. I forgot my clicker. So, 15 years ago, on the 10th of February 2009, that's impressive. 15 years ago, on the 10th of February 2009, Iridium-33 collided with a derelict Cosmos satellite, and that makes this event almost an anniversary event because it's just 2 days ago. There's another event that happened during the same year, which was much less noticeable. The EPFL in Lausanne, the Swiss Institute of Technology, launched a CubeSat of 1 unit called the Swiss Cube straight into the field of debris of the Cosmos Iridium collision. And at the time, the responsible of this project, Muriel Richard, realized that this was a major problem as she received a lot of conjunction notification, obviously, for the Swiss Cube. The team with her realized that something had to be done, and after thinking it through and working through the different aspects of it, it came to the conclusion that what was missing is a tow truck. A few years later, I met with Muriel in 2017, and at the time she showed me the curve of space debris that already looked like an exponential. And we had a conversation about it. She told me about her mission, and I asked her, okay, what do you want to do? Do you want to remove one satellite, or do you want to clean up space? And she tells me, I want to clean up space, and that felt just an incredibly ambitious program. For me, it was obvious that we needed to have a viable business model to make this work, right? How can you clean up space if you need to be able to fund it? So you need a viable business model. So this is the first thing we started looking at. How can we build a business model that makes sense? And when we did that, there's a couple of predictions we did. First, we were not about to build a company for 2018. We were building a company for 2025, 2026. Why? Because we thought that at some point we'll be facing the wall and we'll have no choice but to intervene and correct the problem, right? And our expectation is that the world in 2025 will be very different from the world in 2018. So we were building a company for the future. And part of our predictions was that there's not going to be a tender for a debris removal mission before 23, 24. We tried to make our prophetizing predictions of the future. And so we created the company in 2018, obviously struggled finding investment because everybody would say, there's no policy, there's no reason why anybody would pay for that. And so we got started like this. And in 2018, in September, received the tender from the European Space Agency for the first removal mission where actually the objective was to pick up an object from the European Space Agency by 2025. We applied. At the time, we had only 2 employees, built up an industrial team, applied to the tender in competition with 12 industrial team, and in 2019 won the tender in competition with Airbus, Thales, and Avio. This put us on the map. So the question for me now is, why are we here today? Right? Why are we in this event today? And the reason why we're today, in our perspective, is because there's no servicing in the space industry. This is why. The space debris is just a side effect of an industry that doesn't have servicing. You would never start the car or the transportation industry without garage and tow trucks, as you would not run an aviation industry without maintenance, corrective, preemptive, and reactive maintenance. Those industries, or the shipping industry, those industries don't work well if they're not maintained. And the problem we have in the space industry is maintenance is missing. There's no servicing capability in orbit for an infrastructure that is worth already $300 billion for the live operation. For us, it became really clear working on it that this was the problem. Let's hope that works. Next slide. So the other element that happens in this industry is that it is rapidly growing right now. So not only are we in the car industry that doesn't have a servicing, but the traffic is exploding over the past few years. And you can really see how this evolved over time. And this is a transition. Yesterday we talked about Moore's law in the space industry, which is kind of an interesting way to look at it. But what happens with this is obviously there's a lot more and more opportunities where servicing would be needed. And beside the fact that there's satellites that fail in orbit, which happens, right, that there's need for more servicing, there's also starting to see some policies changing and the reaction of launching states changing. And one example here is the FCC that applied for the first time a fine for space debris just a few months ago. So what we see, when we started the company, everybody told us there's no policy, right? There's no reason why it would change. Why would people operate differently tomorrow than today? There's no motivation for it. There's no stimulus for it. And what we see is that actually the policies are changing faster than what we expected. So between measures taken in the US, right, by the FCC, the net zero charter policy launched by the European Space Agency, the European Commission that is working on space regulation right now, the UK that are regulating. So things are moving rapidly today, much faster than anything we had predicted prior, which is a good sign because this is a problem that can be addressed, that can be solved. So we work on this first mission with the European Space Agency. This is an animation of the Clear Space One program, where the objective is to go pick up a piece of space debris, demonstrate a non-cooperative capture in orbit, which is really a difficult feat to do. It's like providing roadside service to a car that is orbiting at 28,000 kilometers per hour in the void of space in microgravity without friction. It's really hard to pick up an object like this and to autonomously do this kind of operation. So we've been working on this program with a team. This is a very ambitious mission that has been driven by the European Space Agency, showing leadership on pushing those strategies and those technologies forward. So what we're focusing on is obviously disposal. Interestingly, everybody would tell us when we started, nobody's ever going to order debris removal mission. In our 2 first missions we work on are debris disposal. The other one is mission extension, right? As soon as you can pick up something in space, you can also extend its life, or you can transport it somewhere else. But over the long term, there's many other services that can be built out of those capabilities and technologies. And it essentially changes the game of how we can operate in space tomorrow. And this is really the interest. That's what we're after. So it's a much broader perspective than just looking at, okay, we have to remove space debris. Yes, we do. We have to sort out the problems in orbit. But we have to create a system that is self-sustaining and sustainable. So today we work on 3 missions, right? It's not just a plan. We also have missions we work on. Clear Space One is a €100 million budget to remove a piece of debris. The flight plan is on end of 2027. It's quite a challenging exercise with quite some technological development where all the robotics part has to be developed, validated, tested on the ground to make sure it works. The second mission we work on is with the UK Space Agency, where the objective is to do a reusable vehicle. So the UK space mission has as objective to remove 2 objects in a single mission and be ready for refueling. So it's already the reusable platform for servicing in orbit. The 3rd mission we work on in collaboration with Intelsat is a life extension mission. This is also under an ESA development contract for the development phase of the technology, bringing this to orbit, but then it will swap over to a commercial service with Intelsat for the life extension of one of their satellites to demonstrate the complete value chain of how do you pick up a live satellite and extend its life. So those are 3 programs we work on. And the approach is, obviously, we could approach it with a vertical integration where we do everything ourselves, but we realize that we will never be at the level of maturity we need to be reliable on that kind of services if we do everything by ourselves in the time frame we wanted to. So we decided to focus on a few core IP in technology. One is operation, mission design, services design, the navigation, right, and the robotics in space. For the other elements, we can partner with people that are more experienced than us, right, that can make it cheaper, more reliable, faster, that already have flight heritage, that can demonstrate that it can work. So typically, we're not going to redesign onboard computers or power systems or structures, thermal or other aspects. And this is all implemented with an approach where we structure, we productize at the building block level, which gives us the flexibility to be able to adapt to different mission profile quite easily. So this is how we approached it. The other element that is kind of interesting in the way we approach the things is that this is not a local solution that is needed. This is a global solution. This means we cannot build that out of a single country and hope selling it to everybody. And we realized that very early on. So if we want to be successful in the UK, we need to have a UK startup. There has to be UK clear space led by a UK entrepreneur that sells to UK government, that works with the UK ecosystem and builds something. And this startup can build on the heritage, experience, and competence that we have in Switzerland. So we approach that, it moves a little fast, in a way where every time we build an entity in a location, we hire an entrepreneur, and it's his startup, right? But he benefits from all the rest of the group of startups that can to go faster, to go much quicker, to be able to provide proposals and win them. So in the UK, we set up the operation in the UK. 3 months later, we won the first contract. And this was only possible because of this way of collaborating together. So we've got an entrepreneur in the UK. We have Sabrina that came from Thales that is in Luxembourg. We have Tim McLeod that is in the US. And we're expanding this way, which allows us to bring out a larger talent pool and grow quickly and build up on what has been already achieved and share IP competences across the group. The other element that's really important is that if you want to produce a change, you have to talk, right? You cannot just make a mission that works. You have to make a mission that speaks to the emotion of the general public, right? What would the budget of the space agency be if every time there's a mission, the whole country has a swell of pride, right? How do we produce change is by inspiring the public. And we were amazed to see how much traction this subject had. To give you an example, I had a discussion with a journalist from Les Echos in Paris, and I tell him, we were fascinated to see when we made the first publication that we had publication. One of my classmates from Stanford called me from Medellin in Colombia telling me, you're in the morning press here, how did you do that? And we were fascinated how much traction the subject had. And he said, I know, right? If only drinking water had the same level of traction, we would have solved a lot of problems by now. So you need to have a subject that has substantial traction. And we have been lucky that has been a huge amount of traction, in particular behind the Clear Space One program, that allows us to push through important messages. But one important part is that we have to build with one important dimension of space mission is human emotions. So you have to speak to the emotion, tell a story, and then make the tech work. And that's what we try to do. To illustrate that, I have a last video to show you on how we communicate around our mission.
Séparation Clear Space One.
So to add to this, and I see that I still have 7 minutes left, so I can bore you a little longer, right? It's unusual for me to be early. Does happen. But a couple of things. First, one comment about the video. My daughter, when she watched it, she told me, so you never capture, right? And I tell her, well, that's on purpose. We want people to stay hungry for our mission. And if you feed them everything, then they don't remain. You have to keep the hunger in the communication. Another really important element here is that one of the key elements today to get those technologies to develop to where they need to be tomorrow is in which phase of development they are, right? What is the maturity of the market, and what is the phase of development? And the maturity of the market right now is that we're in the pioneering phase, right? The pioneering phase is when people pay to make sure the technology actually exists. And that's what's happening with the UK, with the European Space Agency program, with the UK program, with the JAXA program, where Astroscale is driving. Well, in the UK, we are in competition, which is a very good competition, right? They're phenomenal. And so this is the pioneering phase. The question then is, who are the early adopters, right? What kind of mission will be the early adopters for that kind of services? And what is the arc of development of that kind of technologies so that we get to an industry where servicing is just a natural part of the ecosystem? And that's going to take a few years, right? We know that it's going to take a few years. This is why we got up on this mission way before people would believe that this is fundable, right? Which is not the case anymore. The event of today is a good example, right? People realize today this needs to be funded. This is the future of how we're going to operate in space. And for us, it's really important to have the clarity on how this curve evolves over time. Another element that I wanted to share with you, because here you're working on policy making and how those policies have to be, we had a lot of debate about what kind of policy have to be applied and what kind of standards in particular have to be applied for that kind of space mission. You're going to enter in contact with an object in space. You might break something, right? You might break an antenna or some part of the object you're going to pick up, and that might remain in space, right? Can you produce debris while you remove debris is an important question to ask, right? And the answer is certainly probably not. You don't want to produce debris while removing debris. But the question is, what kind of standard in which phase of maturity of an industry should you implement? Imagine you would use the standards of safety of the car industry today and apply it to the first car in history. It would just kill the industry. So you need to have an approach where you know where you're going in terms of what kind of standards you want to have tomorrow, but you know where the technology and the capabilities are, and you make sure that this actually happens. Because you will get to those standards. It's just that you cannot apply standards of today to the first car. It's not possible. So those are some of the subjects we've been working on over time, over the past couple of years, also with the European Space Agency, with the UK Space Agency, and we're definitely very open to discuss it here as well when it comes to policy making, to standards to be implemented for that kind of operations in space. But the good news is that the future is bright. The future is bright means we have today the capability and the solution to solve the problems. There's a lot of problems out there, but we have the solutions to solve them, and to produce a future that just makes sense. And this is the adventure we're on today. Thank you very much for your attention.
The future is bright indeed, and it's looking even brighter with conferences like this held and conversations happening. After Luc Piquet's wonderful keynote on the mission to remove debris from Earth orbit, our focus now shifts to panel 1, where experts will discuss space debris mitigation and removal. To hear, please welcome on stage our moderator and panelists. And dear panelists, please take your seats under your pictures.
morning. I feel we're so far away. Today we have a very exciting session that brings multiple perspectives about how to tackle the challenge of space debris. We will delve into the difficulties of developing technologies in order to have it mature enough to be able to demonstrate, to have in-space demonstrations, and how funding can play a significant role in their materialization. With me today, we have Dr. Maryam Nuh, who is the Vice President for Future Economies at CAXT. And we also have Mike from the Chief Technology Officer from Astroscale, and Luke, who spoke a few minutes ago telling us about ClearSpace and their endeavors, as he is the CEO of ClearSpace. Good morning, and thank you for being here. I'm going to give each of you a minute or so to introduce yourselves and discuss something that you would like. Dr. Maryam Noor.
Thank you so much, Masha'il, and it's a pleasure to be here with you today. So my name is Maryam Nuh. I'm the Vice President for the Economies of the Future sector at King Abdulaziz City for Science and Technology, CAXT for short. So CAXT is the National Research Labs for the Kingdom, where we work on R&D and innovation. We have started working within the space industry since the early 2000s with launching of more than 14 satellites. Our focus was between building satellites for Earth observation and for communication as well. We're currently looking at working on several kinds of missions, from focusing on subsystems, different kinds of sensors, and of course, given the topic of today's, working on developing technologies that could contribute to the removal and limitation of the space debris element. So that include working on robotics technology, developing AI and machine learning algorithms to help with that sort of advancement within the debris identification and removal as well. I'm looking forward to the panel and excited about joining you here today. Thank you.
Thank you. Mike?
Thank you very much for this opportunity. My name is Mike Lindsay, so I'm the CTO for Astroscale. I'm always thinking at Astroscale of the next mission. What is the next technology we have to pursue and develop to make sure that the solutions that we have are going to be, as Luke put it, self-sustaining. We have to support this mission with a business plan, and we also need the policies that support it and enable it as well. So thinking about where the technology fits in the current political regimes, the business plans that support it, it's uniquely challenging but very rewarding. So a bit about myself, a bit background. I often get the question how I ended up moving to Tokyo to work on this project. So stepping back a number of years, the OneWeb constellation, as we know it, first came to life on my computer screen. So I was lucky enough to kind of help design that constellation. And it's a very inspiring mission to spread that connectivity. But I remember my boss at the time, looking over my shoulder at the constellation as it was being animated, said, Mike, if you screw this up, it's not going to be called the Kessler syndrome. They're going to call it the Mike Lindsay syndrome. It was very daunting to see the potential outcomes that could come to fruition if we weren't being responsible. So that kind of inspired me to think more proactively about what we need to do to be responsible, to take action to secure a sustainable future. So that led to OneWeb preparing their satellites with docking plates on board to make sure that they are prepared in the worst case to be removed by a future servicer. And after a few years there, I decided to be a direct part of developing the solution for active debris removal, end of life, and other in-orbit services. So took the leap to Astroscale in Tokyo, where I'm now CTO. So thank you.
Thank you. Luke?
Should I present myself again? I can do that. I've got 3 minutes. So
we can skip if you want.
Yeah. Yeah, so I think I explained a little why we did what we did in the presentation before. All I can add to it is just say that it's incredibly inspiring to work on a major issue or a problem that can make a difference. And I can see a lot of young engineers getting really engaged around it, and I think it's phenomenally inspiring. And then I know Mike for a while, because at the very beginning when we worked on our business plan, our first meeting with OneWeb was with Mike. So it's great to be on stage again with you.
Thank you. So my first question goes to you, Mike. So Astroscale has several solutions to either remove or mitigate space debris. It has also demonstrated some in space. Tell us more about this and where the technologies are in terms of in-space demonstration and or the technology readiness of Astroscale.
Certainly. In 2021, we launched our ELSA-D mission. This is end-of-life services by Astroscale demonstration. And this was actually a joint stack spacecraft, so two different spacecraft launched together. And once in orbit, we separated the two spacecraft and immediately demonstrated capture. And this was a critical element to demonstrate that we could use a magnetic capture device on our servicer to capture a client that is fitted with a ferromagnetic docking plate. And so if you want to talk about steps that can be taken today to be proactive about sustainability, preparing satellites for eventual removal is one easy investment to make in securing the future. So we've demonstrated that this, in fact, does work. This technology is demonstrated in space, and we'd like to see more preparation from operators. The servicer also did autonomous relative navigation, looking at the client spacecraft, keeping a position autonomously. And we also demonstrated that we could transition from a distance of about 1,600 kilometers using ground-based SSA methods to navigate our servicer close enough such that it could transition to its onboard sensors. It could locate the client object and then switch from an absolute navigation method to a relative navigation method. In this case, this was about 160 meters away. So a number of technologies that we're very happy to have demonstrated in space. And I mentioned this yesterday, but we're very excited because in just 6 days, we're planning to launch our next mission. This is the ADRAS-J mission, which is part of the JAXA's CRD2 Phase 1 program. So this mission will be launching from New Zealand on an Electron rocket, and this will be the first, to my knowledge, the first mission that will actually approach and rendezvous with an actual piece of space debris. So we're getting very close to a spent rocket stage, this is H2A upper rocket stage. It's been in space for a number of years. We're going to get close to it, take some pictures, infrared, LiDAR data will be collected. And what we're going to do is assess the state of this debris, see how it's moving, how it's tumbling, what is its condition, really trying to determine and make sure that it's safe to approach with a follow-on mission that will then go and capture this debris, grab it, and then bring it out of orbit. And for that, we're developing robotics in-house that will do the grabbing and grappling of that object.
So do you think, we have some time, so I wanted to ask a follow-on question. Do you think that this technology could also have dual-use purpose? So for example, you could use the same technology, capture an enemy satellite, and be like, all right, I'm going to destroy you now.
It's certainly always a concern and reality of any technology. It does have that dual-use nature. It's certainly not what we're developing the technology for. We're very mission-driven on the sustainability issue. But yeah, that's always there.
Do you think that will then cause some policies and regulation to be in place for these technologies?
Yeah, I think that's only natural. Tread carefully, but make sure we're considering all angles of technology development. It's part of being responsible in developing and having the supporting framework. I don't think it's going to hinder the technological progress, though.
Great, thank you so much. So my next question will be to Dr. Mariam Nouh. So from your perspective as head of economies of the future at CAXT, what do you think is the economic risk of space debris on future satellites and constellations? And how can R&D help us overcome these risks?
Well, of course, there is a huge economic risk with space debris. So we're talking about damage and destruction of on-orbit satellites that may be operational. Usually, governments and private sector launch satellite to provide a service to generate profit and create the economy or space economy. So the more debris that is out there, the higher the risk of either damaging the current services that are being provided, interrupting these services. So we're talking about communication, internet, providing internet from space, looking at scientific research disruption, climate change, and so on and so forth. So all of these would, as more debris is out there, the higher the chances of these services being disrupted and goes out of service. Another economical risk is related to insurance premiums. So the more chance that a collision would happen, the higher the insurance would be. So it might deter some of the, let's say, small or startup companies to actually enter the market in order to launch more satellite and provide more additional services. Another important element as well is related to the operational cost. So companies would have to, as was mentioned previously, develop techniques and invest more in R&D and developing technologies to sort of mitigate and maneuver these kind of different obstacles in order to lower the chances of such collision to happen. Definitely when we talk about large constellations, this would increase the possibility of having more and more collisions and possibly reaching to the collision phenomena with Kessler phenomena that one collision would actually expand and cause more and more debris to happen. So of course all of these are risks. Definitely research and innovation comes at the heart of fixing or let's say limiting the impact of these risks by investing in material science to, for example, develop material for satellites that can lower the impact of debris. Also looking at power systems, looking at robotics technologies. All of these are enablers to implement, not only to limit the number of space debris, but also to prevent it from the first space. Thank you.
Thank you. So basically we have a few data points. One, that there's a huge risk on the economy if we don't do anything. Number two, we know that the debris is increasing. Number three, we have two companies, so when they go to IPO, start investing in them because they have a very high chance. So my next question is going to Luke. Luisella Innocenti, former head of Clean Space Office at ESA, has stated that the technologies to remove space debris exist, but putting them together to actually demonstrate removal in space is what's difficult. How is ClearSpace bringing these technologies together to do this, and how soon will we see you demonstrating it?
So yeah, I think she's right on the fact that most of the technology or the advancement, the TRLs of the technology are where they need to be to provide that kind of services in orbit. And she's also right on the fact that putting them together, making them work is really the hard part in the exercise. There's been multiple attempts, multiple challenges in the space industry overall to push the things forward. So there's getting those services to a level of reliability and cost that really makes sense is the big challenge in this exercise. We have been spending quite some time now really diving into the details of all the implications of the choices we need to make this reliably fly. And some of the choices lead us to choose more safer or for reliable technological choices initially, right? Mostly because we think the first missions have to work. We have to get to a level where we sure that the system's going to actually perform in orbit, and we can really focus on the part which is the hard part of which is the capture, the rendezvous and the capture itself, and then navigating the stack, right? You need to be able to navigate a stack in orbit. You have to know where the center of mass is. You have to push through the center of mass, otherwise you just produce rotations. So there's quite a few problems to solve, including the visibility of the satellite in orbit, when you see it, when you don't, what you want as exposure to be able to handle those operations, what you do on the ground, what you do autonomously on board. So that it's a really complex exercise, and certainly my neighbor on the right knows how difficult it is. But the technologies exist. It's really a question of getting them to work reliably, getting them to work together, make the right choices in terms of how you maintain the right level of reliability of your system and the right level of price. And I think this is the main challenge. Our objective for Clear Space One is a flight in 2027, right? It might seem far away. At the same time, it's really close. We had often discussions with investors that told us, why don't you do that in 2 years, right? And our answer to that is, well, you can build a cart in 2 years, but a Formula One takes 5, right? So you need to make sure that what you put in a mission like this is actually going to work in orbit. And so I think, yeah, the technologies are very mature, right? There's a lot of things that we can use. Processing power has to improve, I think. That's one element where it's still some development to be done. There's onboard computers that start to have the level of performance needed for the kind of navigation you need to do on board. Getting the reliability, for example, of machine learning on board of a platform like this, or sensor fusion, is still some level of challenge at this stage. And then obviously the robotics part. So we still have a lot of work in front of us to get to orbit and make it safely.
Thank you. Yesterday at dinner, you mentioned to me that initially the mass was going to be much larger, and then you decided to change directions because of the requirements. Can you tell us a little bit about that?
Yeah, one of the challenges we had initially is, what is the probability we can tolerate for producing space debris during a mission like this, right? And obviously the standards defined today are very constraining, right? We had a requirement, for example, of 10⁻⁴ of producing new debris in a mission like this. On the first exercise, where there's so much unknown, it's really hard to guarantee you're going to be in there, so you have to do all the analysis to make sure that you actually fit in there, that you don't have an escape of the object during the capture, for example. That's one of the requirements. There's a few other requirements that were that came up during the execution of the program, which essentially pushed the initial design of the Clear Space One mission way above what was in terms of budget possible. So we had to review that, right? We reached a mass of about 750 kilograms, and we could reduce that. We could get to an agreement with the European Space Agency to review the standard. We have also to change object. The Vespa part that we had in the initial contract is at between 600 and 700 kilometer altitude. So if you produce debris at this altitude, they will remain for 100 years, right? They're going to remain for a long time. And the other element is that last year, on the 31st of July, the debris we were supposed to pick up was hit by another debris, right? And that essentially raises the importance of addressing this kind of problem. It generated about 15 observable flakes, right? Parts of that moved away from it, that were identified by Comspoc. And so the level of certainty of the status of the object kind of changed for us, which led to a change of target, which made it possible also to find a target that is lower down in altitude and reduce the requirements in terms of safety. But that speaks to what I said during the speech. I think it's really important to understand that when you're at this level of development, you have to adapt your standards to make sure you can actually do it, learn, right, in the process, and then iterate from there, right? So that drove essentially a reduction in mass of the complete platform, substantial reduction in mass and simplification of the mission profile, and that's what we're going through right now.
Thank you. So my next question is to all of you. And it is, what do you think the most significant obstacle that stood in the way of space debris removal? Is it development, is it funding, or is it policy? Dr. Mariam Noor?
That's an interesting question. I think each of these obstacles that you mentioned sort of interlinked and reinforces the other. So without clear policy, the technology development will be limited. And without pushing of funding streams to advance the state of the current technology that we have, there will be no sort of incentive for standards and creation of standards and policy. So the three elements quite complement each other, and I think they all have to work in parallel. So technology developers has to focus on developing new innovative solutions. Policymakers and decision makers has to dedicate special funding streams to these kind of research and incentivize companies and startups and the ecosystem as a whole to focus as part of their strategy, as part of their mission, to contribute part of their funding towards that kind of technology development. Because usually companies look at the short-term return on investment, but however, focusing research and resources into this might not have the actual quick return. So policymakers having design standards, for example, for satellite that would limit the generation of debris would actually enforce companies and technology developers to limit that effect.
Do you think there's a chicken and the egg problem?
Yes, definitely, definitely.
So which one comes first, in your opinion?
It has to be a parallel effort from each stakeholder and each entity, the policymakers, the R&D community, and the investment for the government as well.
Thank you. Mike?
I'm probably going to say it's funding. You know, policy. Oh, sorry.
I knew that you were going to say funding.
Yeah, policy. There's a lot of work to be done, for sure. And but I don't see, you know, a lack of policy standing in the way of development or the deployment of you know, debris removal missions. And you know, our experience working with the regulators, there's a lot of motivation there. They want to work together with industry to come up with solutions to help with licensing. So there's a lot of support there, a lot of momentum. I don't think there's anything insurmountable about that. And technology, you know, I'm with Luke in saying that you know, the solutions are here. You know, I'm not going to say that with, you know, infinite funding, Luke and I could solve all the problems and take it all down right away. There are some pieces of debris out there that are extremely challenging, that we don't have the exact solution for just now. But right now we do have solutions for plenty of debris that is up there, and so it's enough to get started. It's enough to start removing these objects. I think we heard from Christophe yesterday that, you know, we should be moving 5 or 10 objects per year. So there's plenty of work to be done, and you know, we have enough to get going. So yeah, funding is the big issue I see. You know, we talk a lot about regulations that are incentive-based, the carrot, which is great for looking forward. But you know, we have a debris problem that's up there right now, and it's all based on past performance. So you know, who's going to pay for that? So yeah, that's, I think, the biggest question that we're seeing.
So it's funding to develop the technology, and then the regulators will follow suit because they want you to fix this problem, essentially.
Yeah.
Great, thanks. Luke, what's your take on this?
I would tend to agree. I would just add to the funding that the funding that makes sense is a funding that flies, right? So fund the mission, that makes sense. That makes complete sense. Obviously, there's a lot of funding for technology development, which is great, right? Getting to TRL4, TRL6, and so on. But what really needs to be achieved is TRL9 for that kind of for that kind of capabilities. And so flying is important. I'm also not too worried about policy, mostly because I think it's just going to happen. It's unavoidable, right? And we had the debate sometimes about how active we should be on the politics, the policy side, on our side. So obviously we've got our opinions, right? But from the beginning, our take was we want to be part of the solution, right? Bring the solution. Policy is naturally going to happen because it's just a necessity, right? It's a fundamental necessity. Then once you've got the funding, you can develop technologies. You can bring together young, talented engineers, focus them on a vision, get them engaged in resolving an important problem, and get it through, make it work. So yeah, I think funding, but driven towards specific programs and mission. That's why the Address J mission is so interesting, right? Because this is a very focused funding. Go find out how a H1 body rotates and is the status in orbit is a phenomenal mission. And then go pick it up. I mean, the same for the Clear Space One program or the program by the UK. There's all missions where there's a very focused and clear funding toward a result. And I think this is the important part of it, to my sense. So I don't know if it's the chicken or the egg, one of the two, right? But it's important.
You have 2 and 1, chicken or the egg, and 2 funding. So that solves that. Thank you so much. Then my next question is basically a little bit more philosophical, because in my opinion, space debris removal is the responsibility of the owner of the space asset that's orbiting Earth. Just like we have waste management on Earth, for which residents of the country or city pay taxes, that it takes care of it. Do you think anyone placing things in orbit from here on out should pay a space tax that then pays for your efforts to clean it up? Or do you think policies should be in place to mandate removal, extension, end of life from here on out? One element to think about here is that there's a lot of space debris that happened in the past, so whose responsibility is it? Because some of them don't even exist anymore, and that's where the space tax kind of like amortizes that cost. Your thoughts? Let's start with Mike.
Yeah, as you mentioned, yeah, tax would sort of amortize that cost across, all operators who are launching. The issue is that there are a lot of newcomers to the space industry that are essentially paying a tax based on past maybe poor performance.
We can call it relative tax, relative to their use of space.
Right, so that would be a key aspect to make this, shall we say, fair, based on certain metrics, performance. For example, we see the space sustainability rating. There's a lot of effort that has gone into assessing the environmental impact of a mission. There's a lot to understand about the environment still. Yesterday we heard that NASA and ESA are still unsure about the numbers of space debris in there. So I think there's a lot of ground to cover in terms of developing meaningful metrics. And without those metrics, I think it'd be very difficult to, apply a tax that is both fair and meaningful. Philosophically, I'm with you. Where if someone is impacting the environment in a negative way, then they should be responsible for taking part in remediating that damage done. I just don't know if tax is the right, the word tax doesn't, it kind of pushes people away, but yeah, I think.
We'll change the name, but we'll still charge them.
But yeah.
Luke, your take on this?
I don't have a problem with the word tax. Right. I think it's interesting. In Switzerland, we have a tax on the general trash bag. Right. It's a super expensive bag. Costs like $2 a piece. Right. And the reason why this tax on the trash bag has been implemented is because it incentivizes people to actually sort out the plastics. Right, because otherwise, why would you care, right? But then if your bag is very expensive and you have to buy more bags because you put your plastics and your papers and all the waste in the same bag, so it kind of incentivizes a human behavior the right way. I think if you want to implement a model that builds the right incentive, you have to completely understand the business model of the complete ecosystem, right? How does the business model for the operator work, right? And what will be the right mix between stimulus and incentivizing taxation to push to a certain behavior. And I think it's definitely a complex problem, right? But a super interesting one. It's a really fascinating problem to address, and it needs to really get deep into the business model of the different operators that are out there right now. But then at the same time, I think there's a responsibility of each owner of their own satellite, the ones that have the ones they have up there right now, and it's ownership that should be owned until the end. I mean, there's a impact of you can develop a technology, put it out there, make profit out of it, but if you don't factor in the whole set of costs that are related to the specific technology, you actually didn't do your work, right? You didn't brought the complete exercise to the end. I think one part of it is looking at what is the complete value chain, complete one, up to the very end of the life of a spacecraft. What does it mean in terms of cost? Regarding the past, I think it's a problem of us all, right? It's a problem of us because we want to operate tomorrow in this environment, and the past is actually in the way, right? So the question then is, how do you finance to sort out the past? And there's different models out there where this has been addressed, right? For other types of waste or disasters where a solution can be found. Generally, those are more government-driven and often, and then it can be implemented. At the end, somebody will have to pay for what has been done until now, because we obviously can't leave this up there. And we heard Dan's presentation yesterday about the 50 most risky objects in orbit. I think what needs to be done is pretty clear. It's pretty clear. The question is then how we fund it, and so it can only, to my sense, be a consensual exercise. It can be also a decision by one state to say, fine, I'm demonstrating leadership, right? ESA starts doing this with their own, right, with their own objects. I mean, the Clear Space One program goes pick up objects that are from the past, right? In this case, would ESA want to remove the 20 objects they had on the list, right, of the Clear Space One tender? Not sure yet, but I think at some point most agency will get to it.
Thank you. Dr. Mariam?
I agree with the points that was mentioned by my colleagues here, and I like the concept of, polluters pay. So if you generate pollution, you should be responsible to manage it. But again, the space is a shared responsibility, and what do we do with all the, past debris that is up there? So the concept of having it as a tax pay, as you mentioned, to cover even the removal and the limitation of the past debris, I think it could be an interesting option to look at and consider. Other financing models or incentive models that can be generated for companies who work within the space industry to limit the creation of additional debris with the new satellites and new missions that are being launched. I think this would be of great interest. Again, I feel that the policy makers and decision makers play a big role here in terms of advising how to each nation or each country contribute to the sustainability of the space ecosystem. The space, again, is a shared responsibility that we all have to contribute to, and not one nation or one agency should take that burden alone.
Thank you. One other question. From a priorities perspective, when you talk about space debris removal, what size should we focus on initially, and how can we tackle the smaller ones, up to 10 centimeters or less? Luc?
So we often had this question coming up saying, yeah, but what about the small debris, right? Who's going to pick those ones up? And our answer generally is the saying that I could be fixing the fence, but I'm too occupied running after the chicken, right? So The point is that you have to find the problem at the source. The source of small debris are large debris, so it's kind of an obvious statement that we should start with the big ones, for sure, because those are the most risky ones. Those are the biggest number of small debris of tomorrow. Smaller debris are kind of a really challenging case, right? Mostly because for some of them, very different solutions are needed. I think probably around shielding will be most likely the solution for the really small ones. And there's some sort of an intermediate class where it's kind of a difficult exercise to find a clear solution that can make sense. You can obviously not go from one to the other and go pick them up one by one, because it would just not make sense in terms of propellant equation and how much energy you need to be able to do that. But it's quite obvious for us. We should start with the big ones, make sure that the system as we build it is sustainable for the future, and then work our way down to smaller one as technology develops.
Mike?
Yeah, I'm thinking of what to add to that, because that perfectly reflects my feelings as well. You have to start with the main source of potential small debris, and those are the large objects. This is why we're very happy to be working with JAXA on the CRD2 program, because the H2A upper stage is 3 tons. So starting big. So it's a big challenge. I mean, if you're talking about the philosophy on for tech development, you start small and kind of work your way up. There's an argument to be made there, but the problem is here now. So focusing big for the near term.
I think if I can just add to it, there's another big challenge about those large objects. Is that if you look at the list of the 50 most concerning objects in space, you find out that most of them are rocket bodies from Russia, right there, SL-16 rocket bodies. Obviously, arguably, the US assets are not fully on the list, right? I expect that there's some US defense assets that are not present on this list for good reasons. The point is, how do you address those, right? Those represent a real threat for the space industry of tomorrow, and they belong to Russia, right? So how do you do this? If I could imagine a very daring and bold mission is to go pick up an SL-16, right? Demonstrate, pick up maybe we could even partner on that, right? Do something together. That would be a bold mission. The question is, which country would be able to get to an agreement with Russia for such a pickup?
Dr. Mariam, your perspective? Perhaps from an economic perspective with regards to, so we clean up the big ones, then we go into the smaller ones to tackle those. But also, what can we do from an economic perspective to make sure that, at least in Saudi, we're not a big space debris creator because we don't have a lot of assets. So what should we have as a lesson learned from the previous heritage that we can apply here for the future?
Definitely, as Saudi entering into the space sector, we should focus on the development of our new satellites that we are launching, and make sure that all necessary measures in terms of sustainability and safety are in place. Whether having technologies for like on-orbit refueling, for example, expanding the lifetime of the satellite to eliminate more debris happening, looking at technologies for AI and machine learning to enhance the object detection and maneuvering of existing debris. All of these are technologies we are looking at currently in Saudi Arabia, and hopefully would be implemented in our next mission.
Inshallah.
Inshallah.
Thank you so much for your insight, and I really hope that we have a lot of lessons learned from what we do on Earth, and we can project that out to the moon, and we don't do the same mistakes on the moon. Thank you so much.
What a lovely first panel for today, so informative. And as our panelists delved into critical aspects of space debris mitigation and removal, we eagerly anticipate insights from our next speaker for today, Principal of Launch Space Services, who will shed light on the space debris threats and sustainability approaches. So please, ladies and gentlemen, put your hands together and welcome on stage Dr. Marshall Kaplan.
Good morning to excellencies, speakers, and guests. I've been looking forward to this because there's been so much talk about policies and regulations and costs. I'm not going to talk about that. I'm going to talk about the technologies that are related to what I call the holistic picture of space debris, and give you one or two suggestions about possible solutions which are unique compared to what we've heard so far. And I'm going to, in fact, I was going to think about changing the title of my talk to be more specific, something like a holistic approach to debris remediation and traffic control. And I'll be talking about these topics as we go through the lecture. First of all, what is the debris threat? And I think we've heard a lot about it. It's fairly obvious, although I want to restate a few things that you've already heard. The real underlying threat and concern is the possibility of devastating collisions with satellites and debris. And there have been a few events that have reflected this, and there have been a few other activities such as explosions, breakups, and that sort of thing that tend to create more debris. One major concern is safety for human spaceflight, and that is a major concern because our space station and future space stations will be at altitudes that debris pass through. And there are debris elements in low Earth orbit from, about 100 kilometers or so up to about 1,200 kilometers. The other concerns are that the lifetimes of active satellites tend to be decreased by the fact that they're being bombarded by smaller debris. And also, there's a possibility that you've heard about the eventual jamming of orbits, otherwise known as the Kessler effect. So there's some, obviously, real reasons for concern here. The activity so far, in terms of missing debris, so to speak, collision avoidance technologies have limited effectiveness and require satellites to maneuver and use up valuable propellant. Orbital traffic management is not going to be possible unless we can somehow control the debris population and manage the traffic. And so I'm going to touch base on those topics as we go through this, but I want to explain some of the technical aspects of the debris field. So where is the debris? The debris is in several locations. The most debris and the most concerning debris is what we call low Earth orbits. And lower orbits range from altitudes of about 100 kilometers to about 1,200 kilometers above the Earth. Then there's the SSO, or sun-synchronous orbits. Sun-synchronous orbits are very popular for Earth observations and reconnaissance missions. And there are literally hundreds, if not more, old satellites, active satellites, and debris fields in what we call the sun-synchronous orbits. And the sun-synchronous orbits are characterized by the fact that they pass over the polar regions of the Earth, which is otherwise unusual because most other satellite constellations do not come close to the polar region. So I point that out because this is a key factor in controlling debris. Then there's the geostationary geosynchronous orbit, which is a singularity about 35,000 kilometers above the equator. There's a little debris there, but really not of major concern in terms of threats. And then there's the final one here, what is called the GTO, the Geostationary Transfer Orbit, which is the kind of the graveyard orbit for upper stages that have launched synchronous satellites into the geosynchronous orbit. Now that is a kind of a surprising problem, because there are literally on the order of hundreds of these upper stages that are transiting around the Earth that pass through the perigee or low point below the space station altitude. So the fact that they're passing by the space station and all other satellites as they go around the Earth every 10 hours or so is concerning, because these upper stages are major in size. They're the size of school buses, and they are very dangerous, obviously. When they pass through the perigee, they're going in excess of 10 kilometers a second, which is faster than our orbital satellites, which are going about 7 kilometers a second. So the relative speeds are very dangerous, so to speak. So that gives you a quick rundown. As you can see there, I've depicted the geostationary transfer orbit, the GTO, at the bottom on the right, and the other orbits above it. Okay. So now the next question is, who's polluting space? And the answer is a lot of people. Okay, this gives you a representative relative map of money spent on space programs by country. And obviously the main polluters of the space area are the United States, Europe, China, Russia, and many other smaller companies that launch things into orbit. So this is a pretty good representation of who is putting things up there, and thereby who is creating the debris. All right. I just want to point this out, that the problem is universal and international. Just to quickly review some of the space environmental statistics, you've heard of these, some of these already earlier in the program. The number of satellite launches since 1957 is 6,500. So up to about 10 years ago, the number of satellites, or number of launch vehicles, I should say, that were launched per year were on the order of 50 to 70. We have now exceeded 100 launches a year. So we are really putting stuff up there very fast. The number of satellites total placed in orbit by these launch vehicles, about 16,990. Of those, there are still 11,500 of these satellites, which are mostly expired, except for about 9,000. So what you have is a large number of expired satellites, in addition to debris created by collisions or by explosions orbiting the Earth. The number of objects tracked and cataloged by the tracking agencies, about 35,000 objects, bigger than about 10 centimeters. Now that represents only a very small percentage of the total number of debris pieces. So the real number is much larger than that, and I'll talk about that shortly. The number of breakups, explosions, collisions, anomalies that we know about is in excess of 640. So the total mass of all space objects put into space over the last 60 years is about 11,500 metric tons, which is several million pounds. The number of objects estimated based on statistical models is following. Basically, you got 35,600 space debris objects, as I said, are bigger than 10 centimeters, which is 4 inches. 1 million objects roughly from 1 centimeter to 10 centimeters, and 130 million objects roughly from 1 millimeter to 1 centimeter. Now, the interesting thing here is that there are relatively very few large objects. Most of the stuff, in terms of debris, are smaller objects which cannot be tracked, and we can't even see them. But we do know they're there because we've done some research in the past. In fact, NASA has created a rough graph of the size of the debris versus the rough population in low Earth orbit. This is an old study, so they haven't upgraded it yet, but it's about 25 years old. So in the past 25 years, this estimate has been increased, obviously. Now, just to give you an idea of what's important here, the crosshatched area on the left is a small debris. And you see it's estimated there are a total of 100 trillion pieces of small debris. Now, that goes down to a microscopic size, but that gives you a rough idea what's up there. In the middle range there, that's the range from 1 millimeter to about 5 centimeters, and that's the range in which we can't really track most of those objects, although we're improving it, but we still can't track them accurately in terms of avoidance procedures. And there are quite a few of those I mentioned before. And then on the right corner there are the very large objects, bigger than about 5 centimeters. And there are a total of roughly 40,000 and 50,000 of those. So we've got a wide spread of sizes and a large number of these things, mostly in low Earth orbit. Now, what is this? How do you characterize the geometry, which is very important, it turns out? Okay, let me explain a couple of things. First of all, the population tends to be symmetric. So the debris population has some symmetry. This is important, as you'll see. It tends to spread out around the Earth in such a way that the debris field is roughly symmetric about the axis of the Earth and symmetric about the equatorial plane of the Earth. Now, this is important because this leads us to the conclusion that the pattern of flight is such that the polar regions, or the near polar regions, are much, much denser with debris, as would be the equatorial area. So the least dense area of debris is near the equator. The highest density of debris is near the polar regions. Now, what that tells us is that the generation of debris and collisions is much more probable near the poles. Now, most of the polar satellites are in sun-synchronous orbits. Sun-synchronous orbits, as I mentioned, are orbits that are ideal for Earth observation, but they also require certain consideration because they are creating a very, very dense population near the polar regions of the Earth. As you can see from the bottom there, the density of debris has been increasing the past several years, and in fact, as you see from that diagram in green, the polar regions are very, very dense. So as satellites pass through the polar regions, they are exposed at a much higher probability to collisions. And in fact, the known collisions have taken place near the poles. So we know that's a very, very dangerous area, so to speak. And I'm focusing on this because I'm going to give you a possible solution to the debris problem in a few minutes. And just to point out, when I mentioned symmetry, you see here that the red dots are the debris field of the Chinese ASAT test in 2007. And this is a simulation of the geometry of the situation several days after the actual collision. And you see the red dots are spreading out. They're diffusing around the Earth. So even though you may have a collision in an orbit at a spot, the debris from that collision will spread out. It'll spread out both in long track and cross track. So that's why the tendency is to make the debris field symmetrical about the polar axis of the Earth. And again, this is important because that tells us that our real traffic problem is near the poles. Oops. Excuse me a second here. There we go. The other thing, of course, is I mentioned the space station situation. The space station situation could be critical because every piece of debris that is decaying through the atmosphere and into the Earth's atmosphere when they decay through the altitude of the space station. Now, there's going to be several commercial space stations within about 10 years, and they're all going to be at altitudes that are exposed to debris. And this debris can be very dangerous because the relative speeds of the debris passing the space station could be anywhere from very small to 10 plus kilometers a second. So these could be very dangerous. And in fact, the International Space Station has had several maneuvers made to avoid potential debris. As you can see there, there are roughly 30 times that the collision avoidance maneuvers were executed since 1999. So this is a serious concern because we're going to have a lot of people in these space stations, and we must be concerned about what we have to do, or what we can do, as a matter of fact, to avoid a collision with the debris piece. Here's a list of what are considered to be the 25 worst, or the top 25 derelict objects. And I want to note that the major list here of items are Russian era or Soviet era upper stages. Now these upper stages are the size of school buses, each one of them. You see the one on the left, there's a picture of one. It's 11 meters in length and 4 meters in diameter. And those things are very dangerous in certain parts of the orbit around the Earth. So that may be a concern for the individual pickup of old debris. That would be probably a major target, I would say. Okay, now another question comes up. How long can debris stay in orbit? Well, here's a good depiction of that, the solutions. Most of the effect of debris degradation is due to atmospheric drag. Now, obviously, when you're out in outer space, the atmosphere is pretty thin. In fact, it's pretty molecular when you get above a few hundred kilometers. So you've got things going around at multiple orbits. Things in low orbit tend to decay faster because they're closer to the atmosphere, the thicker atmosphere. Things that are very small, also, if you notice here, the ballistic coefficient is a ratio of the mass to drag of an object. Well, obviously, if you have a very small particle, it doesn't have much mass, but it has some drag. In fact, the drag roughly goes up as the square of the object, and the mass goes up roughly as the cube. So as it gets smaller and smaller, the area becomes more critical. And so small particles tend to decay much more rapidly than do large bodies. And of course, large bodies represent a bigger threat in terms of debris. So this just is a plot of the various things that might happen. To note that the space station itself is about 400 kilometers altitude. It's pretty dense, so it'd be high on that chart. If you look at the chart, if you stop reboosting the space station, within about a month or two, it would decay into the atmosphere. So we must reboost the space station periodically. Okay, so the big question is, must we remove orbital debris in LEO? And the answer is complicated, obviously. For example, I mentioned that the small debris is much more numerous than the big debris. In fact, the small debris that we can't track, can't see, represents 99.9999, et cetera, percentage of the debris up there, whereas the bigger stuff, a very small percentage. Most dangerous debris is in the range of 1 millimeter to larger sizes. So 1 millimeter is kind of the lower end of the real dangerous debris. Anything smaller than 1 millimeter can be not ignored, but can be shielded with spacecraft shielding. And we do that sometimes. Satellites are launched rapidly. Satellite launches are rapidly increasing, as we noted, the resident space object population. And there are multiple new constellations being launched, which will add up to as high as 90,000 satellites in the next few years. About 5 years ago, there were only about 600 active satellites. So this is quite a large increase, and what that means, of course, is the debris density and debris population is increasing and rapidly. So without a permanent proactive debris removal and control program, the ability to operate in space may diminish over time, and in fact it is. Gridlock in LEO is a possibility, and if that should happen, then we would not have access to space. And that would be a major economic and impact on, as well as other things. So, what is the bottom line? Well, let's take a look. Space traffic management, realities. The space traffic management is an international issue, obviously, because satellites all fly over large parts of the world. Without STM, the debris population will likely grow exponentially and may eventually gridlock the LEO zone, as I mentioned already. The complexity of a very viable STM architecture and the existing state of traffic may require a complete paradigm shift in space utility. What I really mean is many things will have to change in terms of how we use space. New approaches to space operations, new satellite hardware, software, regulations that manage orbital assignments, and those regulations, of course, as well as policies, must reflect the available technology and economic pain, so to speak, that has to be expended. So debris removal and control must become the most important aspect of a successful space traffic management, because you can't have manageable space traffic without also controlling the debris. Okay, so how are we going to solve the problem? Well, my, what I would call my rough solution is, number one, have a organization similar to the ITU that allocates the altitude of satellite constellations, because altitude is the only parameter that guarantees separation from debris and separation from other satellites and other constellations. So altitude is something like the radio frequency band. It should be allocated, and maybe a bidding process might be tried, something like the ITU does for frequency allocation. Secondly, we're going to have to probably stop using the sun-synchronous orbits, because they are the igniter for the explosion of debris. If a chain reaction of debris generation is going to take place, it's going to start near the poles because of the density of the debris at the poles. So in order to avoid that in the future, I'm suggesting that we abandon sun-synchronous orbits and possibly even eliminate some of the existing satellites in order to clean up the dense passage over the poles. Secondly, the equatorial plane is a hidden treasure, because by using equatorial plane, we can actually passively, in a smart way, eliminate the small debris without spending a lot of money, so to speak. So my suggestion is to shut off the sun-synchronous orbit, sell the altitude ranges for constellations, satellite constellations, use the equatorial plane for guided passive small debris collection to clean up the area between constellations, make them safer, and remove selected large objects as needed. Now this is a really complex problem and complex technology, and in fact I'm going to suggest that the Saudi Space Agency do some space challenge camps related to the debris solutions, and so that might be a very good way to generate new technologies here in the region and actually make some advances in the debris problem. Thank you.
Thank you, Dr. Kaplan, for your remarks and this wonderful keynote address right before our first break for today, ladies and gentlemen. Please be back here by 12:25, and you'll have a chance to stretch your legs, mingle, connect, and communicate with one another. We will be back here at 12:25. Dear guests, please take your seats. The conference is about to proceed in 4 minutes. Dear guests, once more, please kindly take your seats. We have a very exciting keynote address ahead of us, starting in just a moment. Welcome back after our first break for today, ladies and gentlemen. I hope you had a lovely, quick mingling, communicating and connecting with one another, and had some snacks to power up for our coming up keynotes and panels. So let's start with our space-based space situational awareness, empowering space safety and sustainability by the CEO and co-founder of North Star Earth and Space Incorporation, Mr. Stuart Bain. Please put your hands together for him.
Oh, for a muse of fire to ascend the brightest heaven of invention, a kingdom for a stage, princes to act, and monarchs to behold the swelling scene. These words of William Shakespeare, written for Henry V in 1599, hold as true today as they did over 400 years ago, and hopefully they will spark our imagination. Many have so eloquently captured the challenge that we face in space with congestion, with problems of collision, and all the space traffic management and aspects that go with that. It's an existential threat to our economy and to our future. And I quietly accepted this challenge over 12 years ago when I joined my partners and created North Star Earth and Space. Our fundamental approach at North Star has been to answer a very specific question. How do you monitor 300 trillion cubic kilometers of space so that we can navigate safely and preserve that environment? Answering that question is the gift that keeps on giving. So let me take you through some material. We all know the problem, I don't need to repeat it, but it's a dynamic, like theater, like Shakespeare. It's a positive and a negative. It's an antagonist and a protagonist. The antagonist on the left with 125 million objects, the protagonist, the possibility of the economic boom that comes from the space economy. It's an enormous opportunity, and it's probably the biggest influence that we'll ever see in our lives, is the influence that space will have on our economy. So what does North Star do? What is the challenge? Everything in the light gray zone is an area that is very difficult to monitor from the ground. So we are limited as to how much we can visit or revisit objects as they travel through space, as they go through any orbit in near Earth orbit, if they are traveling over the areas that are slightly shaded. They're restricted due to geography or geopolitical reasons, and so we cannot monitor those areas. It creates what we call the gap. And as we say in Britain, North Star is here to mind the gap. So we've created a space-based system to answer the question that I posed earlier. A space-based system that is not restricted by ground and that is not restricted by weather or atmosphere, but that is up in orbit and is able to actively scan space from a low Earth orbit that is sun-synchronous, and it is looking at objects actively as it passes through. So with this capability, North Star has invested over $150 million over the last 12 years, not just to build the infrastructure, but to develop the concept of operations and to build the algorithms with astrophysicists, orbitodynamicists, scientists, programmers, etc., so that we can realize a service that can be delivered, that can deliver contextualized information to its clients. So as you can see, once you put up a constellation, which is what's on the right, of satellites, and the beams of light are merely illustrations of how we would be collecting images from satellites. 24 satellites operating in a constellation using the sun as the muse of fire, as Shakespeare put it, that shines on the objects and gives us the reflection so that we can see multiple times during a single orbital pass, hence reducing the error ellipsoid of that object, or the error associated with the location of that object. Because navigating in space and keeping using orbits that we have highly densified with activity, one way to get through it is through precise navigation. So the accuracy and the precision of your monitoring is something that North Star is contributing. What you see on the back is an artist's rendition of Quadrilane. That's $1.6 billion of US government investment to build one space fence radar system. So one space fence radar system, not nearly covering the same amount of space as you could with a constellation of commercial sensors. So we had a monumental moment this past month, not more than 2 weeks ago. We launched from Mahia in New Zealand the first 4 satellites of our constellation. And I hope if I press this button, you'll see the video. Could you play the video?
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and we have liftoff.
Electron has successfully lifted off from Rocket Lab Launch Complex 1 with its Spire and North Star payload. The rocket is on its way to low Earth orbit with those 4 satellites on board, now T plus 40 seconds into flight.
MECO confirmed.
Payload 1 and Payload 2, deployment confirmed.
There we go, the first 2 of 4 Lemur satellites have been deployed from the kick stage. Let's keep a close ear out for the second deployment milestone, sending the last 2 satellites for this mission off to work in LEO.
Payload 3 and Payload 4, deployment confirmed.
That was Mission Control with the good news. We have successfully deployed all 4 of Spire and North Star satellites to orbit. And with that, we have completed the primary mission for our 43rd Electron launch.
So the launch of those satellites, as you watch this video of our concept of operation going through LEO, MEO, GEO, and beyond into cislunar, is a first for space, and it's a first for space-based space situational awareness. It opens the door to a new age of possibilities to preserve and protect this environment, but more importantly, for humanity to sustainably grow within this final frontier of limitless economic and scientific potential. Saudi is the first nation in the Middle East to go into space. They have the highest performance network system for 5G connectivity. They also have a very interesting first position in the world for connectivity of roads and infrastructure. And so these two achievements, amongst many that they have put in place as a part of their Saudi 2030 vision, shows what can be done when a country puts its mind to doing something. And so we can imagine what else could be achieved when they put that into another dimension of space. North Star offers a GPS system. Play the video, please. A GPS system for space. Consider back to the 1970s when we had a GPS system that was created and we didn't really know what to do with it. And now think about how every aspect of your life is driven with GPS, from taking an Uber to ordering something for dinner to picking a place where you want to go and entertain yourself. It's become a part of our fabric. It's part of our economy. And the same system or type of system is necessary if we are going to expand our economy successfully into space. All of this has been awakened recently with this new step. The Saudi Space Agency has honored us and has honored North Star with an MOU, and the entire space community for that matter, with this gracious and generous gift of hospitality given from the heart. And I'm sure that it was strongly influenced after my discussion last night with Mohammed Al-Tamimi, with his one-year stay in Glasgow, my family's hometown, to complete his master's degree at the University of Strathclyde. I wish to honor this remarkable gift that has been given to us in a perfect sentiment, with a commitment from North Star to join with the Saudi Space Agency and your community to make every effort to support you in your goals and the inevitable challenges that they will present. To be humble and honest, North Star's gift is our team, it is our curiosity, it is our innovation, it is our intellectual property, and it's our unwavering commitment to resolve this global challenge. At North Star, we've always held the philosophy that the challenge of protecting and preserving the environment of space is something that is not done individually. It is something that must be done as a collective. There you go. So we talk about community, and we talk about the partners that we make, and here's a sample of those who have helped us get this far and those who have just recently joined us to take us into the future. And as you read this eye chart, let me fill you with some thoughts. Within our sights is firmly fixed the big play, beyond the debris, beyond the problem of congestion in space and all of the concerns that we've raised today. And it's a space-based economy that is driven by high-performance systems, state-of-the-art data, data analytics, interconnectivity, machine learning, and artificial intelligence. We are sobered by this unavoidable existential rite of passage to earn our place in space rather than simply conquer its pristine environment. Space was and never will be ours for the taking. It's not ours to take. We are graced with its presence and must respect its majestic gift with our actions. The test is us, and the price of accessing space depends on us getting out of the way. The compelling question lies in our ability to step out of our respective egos, individually and collectively, and meditate on the supreme value of our interdependence upon one another. In the Buddhist meditation, sunyata, the number 0, the concept that I am nothing in this universe other than my interdependence on others, and meditating on the need to have that interdependence to get to a higher level. We spend 2 seconds on this planet relative to its entire history, yet what we do in this lifetime, as Marcus Aurelius said, echoes in eternity. Performance. Let's let performance be our guide and our measure. By supporting one another, and supporting one another with humility and respect, a fundamental ingredient to success of any mission whether it be to space or any other kind. In this way, we will be able to bring our individual gifts to the table and complete the puzzle and solve the current riddle. Saudi's Vision 2030 is bold and ambitious. For me, it embraces the ideal of always doing better, going farther, and achieving more. It honors its past with a bright and sustainable future. Let this be our guide. Just as we witnessed last evening the hard-fought and lengthy historic battles that defined this country, we must recognize that we are the warriors of our time, and our future generations are relying and counting on us so that they may enjoy space and all of its magnificent wonders. Let this be our sustainable narrative, that future generations will echo of our great endeavors. Thank you.
The past and the future don't usually meet, but Mr. Bain managed to take us to space and to Shakespearean times all at once. We thank you for that. Now, navigating to the new frontier, ladies and gentlemen, is going to be our next panel. Please remain in your seats as we gather our next panel and be back with you shortly. All right, so navigating the new frontier, advancements in space traffic management. Please, ladies and gentlemen, welcome our moderator and panelists. And dear panelists, please take the seats under your pictures. Mr. Moderator, the floor is yours.
Oh, yeah. I think we should wait for it to come up. Welcome to the audience, the space enthusiasts who have remained focused on the conference as we head into the afternoon session. We're actually going to try and be a bit dynamic today. One of our panel members is in a meeting, so he'll join us shortly. But while we're on that, the theme for today's discussion has really been focused on technology, on innovation, and the state of the art that we've become used to and experiencing within space technology. And so what we're going to discuss today is on advancements in space traffic management. And it's a topic that we haven't really covered much. We've spoken about debris, we've spoken about the increase in the number of satellites, and those satellites are increasing due to the continued pursuit around the socioeconomic benefits that satellite missions are going to give us in areas like climate change, in positioning and navigation, and of course, chasing that elusive return on investment that space economy is promising us. And we've heard that with this increase in the number of missions and the number of spacecraft, there is an increase in the amount of, or in the number of maneuvers that spacecraft are going to have to do. And we pretty much are going to reach that tipping point where this is no longer viable for human beings to be solely involved. And so with that, we're going to actually discuss the advancements in space traffic management from a technology point of view. And it gives me great pleasure to welcome not only distinguished, but also highly experienced technical members of the community onto this panel. So first, let me start with Dr. Travis Blake, who is the Space Program Officer for Space Traffic Coordination within NASA. Dr. Romain Lucan, who is the CEO of Eldoria, an innovative space situational awareness company whose focus is on using advanced optical telescopes for tracking and providing services related to situational awareness. Mr. Hamza Hamid, who interestingly brings a space techno-law perspective into this domain, but also importantly, he is the chair of the Space Generation Advisory Council, whose focus is on looking at the future of the space professionals, the young space professionals. And I think seeing as we're really talking about prosperity through sustainability for space, having this view on the next generation of space professionals in this domain is going to be quite important. So with that, and with that introduction, what I'd like to do is start off by setting the scene for this panel discussion. And I'd open the floor on the following point. We know that we're facing this increased congestion in Earth orbit due to the proliferation of satellites. What is the one or two most pressing challenges for space traffic management? And Dr. Blake, if I can start with you.
Oh, thank you. I do really appreciate being here on this panel. This is a topic that I love. I love technology and working in the technical fields. I will try to keep my remarks brief because I could take the whole time. I will also note that in addition to my role at NASA, I also play a very important role with the Office of Space Commerce within the Department of Commerce within the United States government. As Kevin mentioned yesterday, they are the office that has, through Space Policy Directive 3, been tasked with providing a civil space traffic coordination service for the United States and international partners. I'm privileged to be a part of that team while at NASA, and particularly I'm running the research and development activities for the future versions of their traffic coordination system for space, also known as TRACS. We're in the process of putting together our research plan for them, looking ahead to what they're looking at in the additional phases. They're rolling out their phase 1 this September. We're looking at phases 2, 3, and 4 to see what technologies we need to work on to bring that together. Certainly happy to talk more about that offline with anybody. But you ask a very big question, yep. Right? You know, what are the one or two things? I think we've seen in this conference, there's not just one or two things. There is a lot of things that need to be worked on. I would offer up that one of the questions is how much of each one of those things needs to be done. I mentioned on the earlier panel, operating in space is hard, but the uncertainties that we have in operating in space make it even harder. You know, we don't know exactly where things are. We don't know exactly what is up there. You know, there's a lot of uncertainties with your partners who are operating in space with you. They will maneuver without telling you they're maneuvering. So trying to understand how we can find the right technical and policy and regulatory solutions, because it's some mix in there. We certainly could try to do a true, full technical solution, but that seems to be expensive and overly unnecessary. But we can't also try to do all policy. So there's a mix in there, and A lot of people, I have a technology and a policy background, and what I've learned is you can't do one without the other. It does no good to put in a policy or regulation that you cannot meet with technology and operational use. So trying to get the right balance in there to try to find where we should just try to incentivize. I don't like to regulate too much. To incentivize behaviors and norms and standards, and then where can we try to provide technologies in order to provide to close some answers for those uncertainties. I'm very happy to be here with other panel members because we, as part of that solution, are going to be relying heavily on the commercial SSA, Space Situational Awareness community that has built up around this topic area. We are not interested in being able to develop a whole in-house new solutions. We really want to take advantage of the innovation that the commercial market can bring, like my colleagues at Leo Labs, who is great to join us on the stage.
That's a great segue. Welcome, Tez. The audience forgave you ahead of time, so we knew that you were going to join us a little bit later. Maybe just a quick introduction. Mr. Moritez is the EMEA Commercial Director for Leo Labs. And what's interesting is that he's been really working hard to prove the value proposition around space situational awareness and in particular its applications for space traffic management. So welcome, thank you to the panel. We're just starting to have a conversation on the one or two key challenges that are facing the space traffic management domain. So maybe just quickly, I'm going to let Romain give us his viewpoints and then I'll come back to you.
Yes, thank you, Leandra, and thank you so much for having me here. Thank you to the Saudi Space Agency. So just a couple of words about Aldoria before I jump to the questions. So primarily we're a French company. We do space situational awareness with optical sensors and what we call our orbital information system. You know, a little bit like geographical information system now became a usual thing. What we're promoting is an orbital information system that can be interfaced with other players, and this is certainly part of the answer of the question you're asking. You know, of course, you have challenges in data sharing, in the way information is transferred and communicated between space players. I think, yeah, the way things are done in the space community, there are a lot of inefficiencies, but somehow we still manage to communicate and avoid collisions, even if even if it's at the expense of a lot of human time, I would say. But the biggest gap that's really in the community is really the security related to the lethal non-trackable objects. So in particular the objects between 1 and 10 centimeters of size. So there's really a huge gap. I've been in this field for 7 years now. And when I started, you know, I had a couple of meetings with Christophe Bonnard, and this is exactly what he said. You know, when I visited his office at CNES, he said, we don't know, we are not able to protect our spacecrafts from all these objects between 1 and 10 centimeters of size. And then we expected the space fence to come online and to provide part of the solution. And you know, a couple of years after the space fence has been commissioned in the Marshall Islands, it seems like it doesn't really contribute to the global safety. So we're still in the same situation. There are so many debris, we're not able to track all of them. There are so many more satellites, but our ability to track has not really evolved in terms of number of objects and sizes of objects. So basically we have more data on objects that we know already, but we don't have any usable information on these smaller pieces of objects. So
great, thank you. Hamza, maybe you want to come in with your views as well.
Yes, thank you very much, and a big thank you once again to the Saudi Space Agency and all the partners at this conference for having me here. I think, you know, you put it correctly, and I talked about this a bit yesterday. Space is becoming increasingly congested, I think, with more than 3,000 active satellites in space at the moment, and that number looking to grow exponentially in the coming years. The risk of collision and the need for collision avoidance maneuvers has grown over the past few years. I think the European Space Agency has estimated that the chance of a satellite colliding with a piece of space debris larger than 10 centimeter is about 1 in 5,000 operational satellites. And given that, you know, we're almost about to cross that number, the last thing we'd want to see is that many crashes a year. But I think at the same time, these probabilities are reduced drastically with systems as space traffic management and space situational awareness. And this is something that's very important, particularly from a next generation and in a youth perspective. I think the speaker from North Star previously put very, very correctly that it's our responsibility on the present generation to explore space sustainably and with a view towards how future generations will continue to enjoy the benefits of space. I think yesterday I mentioned that at the Space Generation Advisory Council, where we represent more than 28,000 students and young professionals from over 165 countries, we recently developed a document called an Intergenerational Pact for Space Sustainability, and that focuses heavily on tools such as space traffic management and space situational awareness to act as vehicles through which space can be explored more sustainably and with the future generations in mind and with the youth in mind. I think you described me as a techno-legal person on this subject. So I think from a technical perspective, I think the previous speaker pointed out very correctly that one of the biggest challenges to deploying these technologies is the lack of an international framework or guidelines even on data sharing and how there should be transparency in orbital parameters, in objects that are launched into space, as well as how crucial data is shared openly and transparently amongst all spacefaring nations and entities. I think from a legal perspective, the other item that I'd certainly point out is the challenges that activities such as space situational awareness and just looking very closely at satellites and space objects that belong to different countries and to different stakeholders around the world, the legal challenges that exist with that activity, including issues of jurisdiction, sovereignty, the capacity of one state's tool to look at another state's satellite that closely, as well as issues of liability and responsibility should something go wrong under documents such as the Outer Space Treaty and the Liability Convention. I think there's also a need for development of standards and best practices as to how systems like this should be put together, and I think other panelists can certainly contribute more to those. But there are a lot of challenges. At the same time, I think tools such as space situational awareness and space traffic management are critical to resolving or helping with the space debris problem and allowing space to be explored more sustainably. So I think we certainly need to address these challenges head on.
Great, thank you, Hamza. So finally, you know, we're hearing this common theme of the interplay between space situational awareness and space traffic management. And I know that, Mr. Motez, you're quite active in that domain as well, actually having seen both sides. So maybe tell us a little bit about the challenges from your view.
Yeah, so first of all, kindly excuse me for being late. I literally had to run over here and I thought I'll make it. And thank you for having me. So I'm going to give you a little bit of an operational perspective. Leo Labs, we've been doing this for quite some time. And when I first joined the company in my previous role, I worked closely with SpaceX and OneWeb and Planet, Maxar, and many other customers and partners that we really cherish our relationship with. And we see that it really is summarized in two words, accuracy and transparency. So what does that mean? I will give you 3 examples. One of them is orbit raising. So if you are deploying your train of assets and you need to go through another constellation, you need accurate GPS information. Some spacecraft don't have that capability or have some challenges. So you need an independent source to validate and to really provide that other input so that the other constellation knows how to take your plans in consideration. Another thing is on-demand screening, or what we call special screening. As we increase the activity, we need to really have the most complete and accurate and transparent database, and we need to have infrastructure that allows for rapid screening. So you always have the latest and best data so that you can operate with it. But the main thing, the main issue, and I would echo what Romain just said earlier, is small debris. So small debris, things between 1 to 10 centimeters, they can absolutely take out your spacecraft. They can cause a lot of debris. And one way of doing that problem, solving it, is to actually solve the problem that we know about. So small debris, they are the known unknowns, But what if I tell you that there are hundreds and thousands of objects that are bigger than 10 centimeters that are actually poorly tracked? So we know about them, we have an idea of where they are, but operators don't have good enough data with high frequency that they can operate in a safe environment and take those in consideration. That's really what we're focused on.
Yeah, great. Travis, you want to come in on this point?
Yeah, let me, I think the discussion on this, lethal non-trackable debris, it's always important to talk about, what we mean by that. We can reliably track most objects that are greater than 10 centimeters, 5 to 10, yeah, mostly. 5 and below, we're getting a little bit on the edge. But, it's important to note that, not all of that debris is lethal and not all that debris is non-trackable. There's an unknown there. One of those areas that we can look at is say, okay, we understand that, from half a centimeter to maybe 5 centimeters is a real important area for us to get a handle on. How do we do that, right? That seems a pretty daunting technical challenge for, name your phenomenology to try to track. One of the things that would be helpful from a policy perspective and that transparency perspective is that I have a suspicion, unconfirmed, that there's a lot more micro collisions happening in space than we give it credit for. We believe that satellites are continually kind of hit by these small pieces of debris. It's important to note it's not just the size. Size in this kind of area is always kind of equated to mass. It's really mass that's important. And we don't have a good characterization of these debris. So they might be centimeters in size, but they might actually be just, a paint fleck that's just large, so not much mass. Now, that doesn't mean it won't do any damage. It just means that you might damage an array, but your system is fine. One of the things that we've been looking at is, can we use all of the 9,000 satellites that are in space now as in situ small debris detectors? If you believe you've been struck by a piece of debris, let us know. I think that would help us start to map out where we believe this problem really is and help us balance between it's not just a technical solution, but it also can just be some policy and some standards and norms there that can help us out.
You've mentioned, as we were discussing previously as well, that it's quite important on this topic of collaboration, and then it's come through this crucial role of data and being able to accurately quantify what's going on. So I mean, here's an interesting, and let's get really interesting into the conversation now, because essentially we have two competing technologies here that can enable this sort of tracking space. I mean, and you've posed another interesting point around the in situ capabilities that we might not actually being applying at all. So, but let me go back to that. I mean, Romain, maybe you could start off by telling us, what makes the optical approach better?
So, yeah, first of all, we're gonna play this exercise of the fight between optical and radar. I think to a very large extent, it's very much complementary. So the optical systems have been used for geostationary Earth orbit monitoring for quite a bit. It's very efficient because you can track the objects all across the night. Companies like Exoanalytics in the US perform basically video surveillance, like 24/7 surveillance almost of the space assets. So yeah, I would say the optical space surveillance technology is very advanced when it comes to geo. But when we started our activity in 2018, 2019, that we really invested in our first optical systems, we realized that the optical technology was really overlooked when it comes to LEO surveillance. So we really designed our systems to bridge this gap. And then you may wonder why. Well, you have first when you have a picture, when you have a streak on a picture, you really have a very fine idea of the angular position of the object, and then you have to, if you set a very precise timing system within your camera, basically your angular position is excellent. So, and then when you have a set of measurements, you can infer, you can perform some initial orbit determination or orbit determination to get the third dimension, the radial direction, and you have a pretty good understanding of the orbit. For example, with one single site for a LEO object, with only 2 passages, we get an accuracy of 100 meters, just with one site. Yeah. With 2 sites, we get it down to about 30 meters, just with two passages on 2 different sites. So this kind of gives you an order of magnitude of how accurate you can be with optical sensors that have a capex that is significantly lower than for radar systems, even though I really appreciate it, and I think the entire community appreciates the effort that Leo Labs has been doing to make this technology more affordable and more accessible to a larger set of customers. So yeah, maybe to give it a first shot, and then happy to iterate.
Yeah, of course. So maybe Mr. Moataz, you want to give us something back on that?
It's a really good question, and I think we need to be mission and operationally focused. What kind of problem are we trying to solve? If we're talking about tracking, then you need capacity, you need scalability. So you need 24/7 highly reliable infrastructure that you can build faster than Moore's Law, than for the launch and for the regenerating events. So you really need to double down on capacity. You need to have accuracy. If we're talking about figuring out tumbling rates, so if we're talking about queuing a system so that you can track an object after it's deployed and so on. So we really need to be operationally driven with regards to answering that question. Yeah, I think that is really like the foundation.
So I think it's out there, Space News had an article. So we recently, NASA helped the Office of Space Commerce push forward 3 pathfinders for them to kind of look at how they can best mix these kind of commercial data sources to meet their needs. And, you know, it's very clear you need both. Not only do you need both, you need them from the Earth and you need them from space. You know, we are kind of agnostic to the data sources. As both colleagues said, you know, there are advantages and disadvantages to both systems, both in terms of the data they can collect, but more importantly, where they collect those data from. You might be able to get 100 meters of accuracy, but it's important to note that that's at the place that you made that measurement. In order to get a really precise, and you know where that satellite comes back at that point again. The problem is if your potential conjunctions on the other side of the orbit, that is where your errors the most from the data you just collected. So wouldn't it be nice to have another system kind of pin that orbit down? So when looking at that, you know, it's really important to be able to have from a user of those data, be able to take all of that in and bring it all together in order to get a more complete picture.
Yeah, Moataz, you wanted to come in on this, and maybe you could also just talk a little bit, if you can, on, you know, we're talking about these autonomous collision avoidance systems, right, and how the data is starting to feed into that. So, you know, while you're responding to what Travis is saying, if you could like maybe talk a bit about on the advanced technology side in Leo Labs on this.
Absolutely. So I just want to give a quick comparison to the transportation business, or shipping in particular. You don't do heavy shipping on scooters. You use them for last mile delivery. So you have different types of trucks, different types of capabilities, and really you have foundational infrastructure, and then you have edge or on-demand capabilities that you require for last mile or for enhanced identification or tracking and so on. So we are complementary, different technologies are needed, but it's really about the architecture. What are you going to have as foundation? What are you going to have as give you an advantage here and there and so on? And I just want to give credit to our partners at the DOC and Travis in particular, because we really think that their mission of creating a new generation of safety services for the globally available, that's a really ambitious and needed mission, using commercial partners, using modern technologies, and we're really proud to be working with them in that capacity. As far as new applications, as far as AI applications in particular, and improving collision avoidance, insights are useful without data. So if you think about AI, if you think about any automated system, it's really about the data that you feed it in, and you need to focus on that data quality. So you need to make sure it's persistent, it's high quality, and it's complete. By complete, it means that you track everything. You don't miss a certain category and so on. And this is really our core mission, focusing on those three parts of data quality to enable that level of automated operations.
Great, thank you. So Hamza, just a quick one to bring you back into the conversation. I mean, Travis was talking about this kind of collaboration between NASA and the industry. I mean, maybe you want to share your views and thoughts and experiences on some of the other international space agencies and how they're collaborating with advanced tech companies, particularly on the topic of space traffic.
Yeah, I think increasingly we see tech companies participating more and more in global dialogues on space policy, on space governance, and on cross-border collaborations between different regions to facilitate thinking towards space sustainability. I think the director of the Office for Outer Space Affairs yesterday talked about more participation from industry, including companies like Northstar, at the Committee on the Peaceful Uses of Outer Space, and the ITU has been a leader in having industry involved in shaping policy and shaping tools for governance when it comes to space activities, and particularly with regard to telecommunications, but now has increasingly started, particularly with the radio assembly, started thinking about spectrum allocation for innovative services, including in-orbit servicing, and I'm sure in the future more towards space traffic management and SSA. So I think there is a role that international organizations and bodies play in the development of standards and best practices, but also to serve as forums to bring different segments of the industry together to collaborate and offer solutions that are interoperable and add value to the community as a whole. Because I think one thing we've learned about sustainability from different industries is that it's hard to do sustainability in a silo or independently, and the more you collaborate with stakeholders from around the world, and the more you sort of approach sustainability with a cohesive vision and with foresight towards international standards, best practices, and mechanisms towards promoting interoperability, the easier the outcomes are to achieve. Yeah.
Great, thanks. And Romain, maybe a little bit of a European view, because you are involved with CNES, and CNES is sort of known for stimulating innovation as well. So maybe a little bit of a perspective on the European innovation ecosystem in this topic.
Yeah. So thanks for asking this question. So we've been working with CNES since 2020. We've seen really a shift in the policy conducted by CNES in the early 2020s, and now, like under CNES leadership, an entire new space ecosystem is thriving in France, and this is part of a broader European trend. So France has always been at the forefront of space technologies in Europe, and now in this new space era, we're also ahead in the transition, or at least we are very proactive, and the French government is being very proactive in this direction. So we've been consulted, we've been participating in the upcoming update of the French space law. We've been contributing to the new space law, space regulation at the European Commission level. In the same way as the DOC is kind of helping to shape the SSA ecosystem in the US. In Europe, there's the EUSST under the European Commission leadership that is trying to combine capacities from commercial players across entire Europe to, or at least about 15 member states now, to build this global SST system for Europe. Probably you've seen the declarations from our commissioner Thierry Breton a couple of weeks ago in Brussels. So now SST is one of the key pillars of the European strategy for space, and space security is something very connected and something for which the European Commission is being more and more vocal as well.
Travis, you want to come in on this?
Yeah, I'm going to say just to kind of follow up a little bit on the autonomy question. This is something that's been a technology thing that we've kind of tried to look at. I think Starlink does an incredible job trying to manage the numbers that it has. No single operator can manage that number of satellites, and the avoidance maneuver is just avoiding its own systems. So they built in an autonomous network to be able to do that with. Which begs the question, what happens when a second autonomous network comes into that same orbital shell? Through a fortuitous stance, I guess, NASA decided to do that. Our Space Technology Mission Director had a mission called Starling, with a G, that was its version of a autonomous 3-satellite network to look at autonomy for future science missions. But they tended to pick that same orbit. So we actually went through an exercise with SpaceX, and we built upon some technology that was out of the Ames Research Center that had to work on with UAVs. And how do you do autonomous UAV collision avoidance in a similar airspace? And they modified those programs such that now, I think it's starting in April, you're going to be able to see the ability to have 2 autonomous constellations reporting out their locations, reporting out their maneuver plans to be able to do autonomous collision avoidance amongst those 2 autonomous systems. That's an important step as we start to look at other ones, and provides a foundation for how we do this kind of collaboration without necessarily people involved through the system. So looking forward to that in April.
Yeah,
and that hopefully works well.
So coming to the data guys again, and that is, to what extent are your systems potentially feeding information, feeding data into these autonomous systems? Are the APIs in place? Is it enabling to be able to do that yet, or is there still some way to go? Whoever wants to start. Do you want to go? Yeah.
Yeah, what we see from the market is that the satellite operators want to keep control somehow on the navigation on the satellite itself. So we can provide them with data, we can provide them with information, with recommendations, but they're going to have the ultimate say on whether or not and how the satellite is going to perform a potential collision avoidance maneuver. So I would say the automation, if any, is going to be more on the operator side, and that's what we've been seeing with Starlink.
Yep. And Motaz?
So for years now, we've been supporting more than 70% of all active spacecraft in orbit. As we speak right now, they're using our data operationally. They're executing maneuvers using our data. And we've learned a lot from those partnerships, and we're really focusing on the things that they care about. So like fully tracked objects and providing additional insights. We use AI and ML in different capacities to help with patterns of life and really provide to them more than just like tracking of all spacecraft. But the data that we have today is operational and it's being used.
Yep. And Travis, how much of a game changer do you think this is actually going to be, or is it just going to be, have to be the way it has to go
the
forward?
autonomous
the
part of it? Yeah, they bring up great points. One of the questions I have is, I appreciated this morning the discussion of the economics for all this. That is a big area that I'm starting to look more into, is where are the economics for how this commercial space situational awareness, data and services, where that goes. And part of that is where are these advanced services that spacecraft operators will purchase from Leo Labs, from Aldoria, I'm sorry, I still share my space, from North Star and others. Where do these data and these services go to do these advanced services that enable this kind of new dynamic, certainly in Leo economy, of in-space manufacturing and orbital servicing, supply missions, tourism. If you need those advanced services, there has to be a commercial case. And if there's going to be a commercial case, it'd be nice for those companies to rely on these kind of partners to do that with, so that they can start to bring autonomy in full to be able to do that, because at some point the coordination problem will become very difficult for everybody to kind of wrap their hands around together. But it does require them to give up some control and trust that that's going to be the case. And I will say that with any autonomy, as we've learned with the Starlink exercise, there needs to be a central function to report out your autonomy. One of the challenges is if you have autonomous systems, but you don't tell us what they do, that becomes my number one biggest unknown. You become my number one biggest uncertainty in space then, because I can't call somebody and ask them what you're going to do. There's a spacecraft making that decision. So that's why we still have to have some central repository that reports out all those autonomous maneuvers as they're known, because what we don't want to do is have two people choose the same avoidance pattern, and now they become a collision risk themselves.
Great, thank you so much. I think that was really, really insightful. It's sort of, as much as we spoke about the advanced technology, we saw how, space traffic management, space situational awareness have to come together. But the overarching theme seems to have been this collaboration and trust component in the entire system for it to work appropriately. So thank you for that. I see we're actually out of time. Again, the audience did forgive you ahead of time for arriving late. We apologize on your behalf. But thank you, everybody. I really appreciate the insights. And to the audience, I hope you enjoyed that discussion. Thank you so much.
Hidden in plain sight is the topic of our next panel. Now, building on the discussions about advancement in space traffic management, we now turn our focus to panel 3, where experts will delve into the topic of hidden in plain sight. So we thank our previous panel and moderator, and please welcome our next moderator and panelists.
Vladimir and Rainer still missing, and by the way, here at the entrance, that's the rhyming gag. I was told in America there's even a TV show which starts like that. So we hope that somebody is not hurt. Thank you so much for coming. We speak today at the middle of the second day when we go to the plain sight, and we heard a lot about regulation. We heard about legislation, about technology, opportunities which are here. And I have a very special panel today because it's, I call it the best party is the mixed pickles party, where 10 people and 50 you don't. So we know in each all, but the field of expertise is very, I would say, scattered when it comes to the space debris and space arena. And I want to discuss in the panel a little bit more on the business cases. Where are the hidden opportunities? Where are the insights where we say how we can do it differently? How we can think differently. And forgive me, this is the leftover of my 7-8 years careers at Apple. Doing things differently sometimes is the pathway also to a successful business. And successful business makes it sustainable. And I remember when with ClearSpace, when Luke was calling me and they said, hey, Frank, Swisscom Ventures will call you. Can you speak positive of our company because we would like that they invest? And the first question to Swisscom Venture was, they say, oh, so you're investing in your operation infrastructure, maintenance. And he said, what? No, we invest in space. But I said, normally you also invest in companies taking care of your cell phone masks and 4G masks. Oh, yes, we do. I said, oh, ClearSpace is the same. The only thing is the infrastructure in orbit. Anyhow, this is a little bit setting the scenes, sustainable business models, where this is hidden, where we will go to. And I give the floor to the audience to introduce, because normally I forget always something, and then the people are mad and come, sad, mad, upset and come later. So Adam, so a VC in space, we have more VCs here in the audience, but how you invest, what you do, what is your profession? OTP.
Sure, so thank you for inviting me, and hello to everyone again. I'm co-founder and managing partner of OTB, that stands for Outside the Box. And we are deep tech investor, and large part of what we do is actually investing in space tech. We've been investing in space tech for the last 6 years. So we've managed actually to start understanding the industry. It's not easy, it's a rocket science. But after a few years spending there, we believe we are capable investor that can bring not only money, but also some insight from the industry. So some of the investments that we did like 6 years ago was the ISI, which is a global leader in SAR constellation, SpaceNow, which is a downstream analytics company, also Hydrosat, which is a leader in infrared Earth observation. So these are some of the companies that we've invested on the beginning of our journey. And with the current fund, we definitely gonna invest much more, and happy to talk about it. One of our, of course, another flagship investments is ClearSpace, which was mentioned just a second ago, that we proudly support. So as you can see, we started with investing in our previous fund with a thesis of Earth observation, but especially non-optical Earth observation. We believe that optical was already quite occupied, and non-optical, like SAR, like infrared, and downstream analytics is something which was at that time, we believe, the most interesting commercially. In current fund, and I hope we're gonna talk more about this, it's more about in-space infrastructure. So in-space manufacturing, in-space management, in-space manufacturing. These are the topics that we believe are gonna be the biggest one in the years to come.
Thank you so much, Adam. Kelly, Vice President, Space Commerce Entrepreneurship at the Space Foundation. Cool title.
Thank you. I made it up, actually. Frank, thank you for having me. It's a pleasure to be with you all. As Frank mentioned, I'm a vice president at Space Foundation. So Space Foundation is a 40-year-old nonprofit. We're based in Colorado Springs. I'm out of the Washington, D.C. office. And we advocate, inform, and convene the global space ecosystem. We really focus on everything from elementary to emeritus. Most people know us by our annual Space Symposium, which happens every April in Colorado Springs. This April will be our 39th. What I do, and where I actually did make up my title, is I designed and launched a new department called Space Commerce Institute, which will be 2 years old this April. And really what we focus on is growth into and growth within the space economy, capitalizing on all the comments and excitement and opportunities and challenges we heard today. There is really a need to be able to put practical and tangible roadmaps in place to make space make sense for people. One of the things I realized is that the industry has a tendency to talk to ourselves. We talk in acronyms, we talk in statistics, but it's really difficult to understand what that means for actual growth. So we work with everything from universities, high growth companies, countries, to really create strategies for insertion into the global supply chain. And I'm very happy to talk more on this panel.
Thank you to be with us, and everybody has the chance to go to space. Amazing event, and of course there's a previous head of technology transfer. They also have the Technology Transfer Hall of Fame. So if you're interested, just Google it. You see where tech from space has ended up in totally different fields than expected. Vladimir, now we come to you're presenting the startups, the geniuses, the people pushing the boundaries.
Yeah, Frank, thanks for having me here today. Thank you to Space Agency for organizing this important event. I'm a CEO and co-founder of Course Orbital, a company focused on developing the enabling rendezvous and docking technology, which enables various types of on-orbit servicing operations, space debris removal missions. And we consider that having that capability, which would be autonomous and reliable to connect and disconnect stuff in space, that's actually one of the critical bricks in building sustainable infrastructure. And following up on what Adam was telling about VCs and their position about on-orbit servicing and space debris removal, I think we should find the business case which will be in the center of this evolving ecosystem. Then all things will be structured in much more clear way to all the stakeholders inside the industry, on a regulatory side, on the business side, for the technology developers, but we'll cover it later.
Perfect, thank you so much. Rainer, we know us nearly since 20 years, so we become then the seniors in space. It's a little bit scaring, but the white is earned, I would say. You have started in consulting, you did projects, you invested in companies, so you have a pretty wide overview, but I think your history and legacy is much wider.
Well, thank you, Frank, and thanks to CST and SSA for inviting me to this one-of-a-kind conference. Thank you very much for that. My name is Rainer Horn. I'm the founder and managing partner of Space Tech Partners, a globally active strategy consulting group that's solely focused on space. We work for institutions, industry, VCs, private equity, sovereign wealth funds, what have you, startups, and in all kind of areas. In particular, in space debris, we work on building new space programs. We have seen some of the results already on stage today. We're working on space policies, on roadmaps, business cases, cost-benefit analysis, and so forth. We're helping startups getting off the ground and investors to make better decisions. In personal capacity, I'm also a very active business angel, investing in space companies.
Thank you, Rainer. And we were sitting, I think still 2 years ago, you're still sitting at the European Business Angel Network for Space, where Candice Johnson is with us. So also another initiative helping the startups getting the wings and to fly. But that's not what we are talking about today. We're speaking about business models. Where is the hidden potential? And I start with you, Rainer Weider-Array, because you have a pretty good overview of the market. When we're looking to the market is, especially when we see the space debris, what we hear the last 1.5 days, is it more on the monitoring, it's more on the hardware, it's more on the trade, where you would see the hidden business models can be found?
Well, I think we see the space debris and the wider space domain awareness activity coming more and more into the limelight of the activity, because we know it's essential and everybody talked about it, even for human spaceflight and bringing rockets to outer space eventually. Now, I think we're at a similar place like we've been in the navigation mapping space and in the Earth observation space. We're getting from the raw data and understanding into a more intelligence, more value-added business altogether. The main applications I do see is understanding, building transparency, building facts and numbers and so forth. Right now, though, the operators employ dozens of people crunching these numbers, having their own proprietary models to try to figure out which of the 1,000 alarms they got, which one actually matters, but they still do at least 100 too many maneuvers. So that's an issue. So there's a huge opportunity for efficiency, and in any business, efficiency by the factor of 10, 100, or even 1,000 is a big cost factor. So it's a huge enabler for people to take better decisions, both first and foremost for operating, second, to know what to mitigate, what to remediate out of space, and thirdly, to keep certain corridors strategically open where rockets can fly.
So translating that, and with the view of industrial engineers, so there is a market for good data. People will pay for better data what they get today.
They will take for actionable data. They will pay for decision tools. They will pay for possibly systems that they don't even know where the data comes from, but they can rely their decision on something that matters. Yeah. Taking a bit of an example, I come originally from the automotive industry, and I worked on satellite navigation systems and got into Galileo and GNSS as a living. We're now talking about autonomous drive potential, level 1, 2, 3, 4, 5, and so forth. Once we reach level 5, nobody's interested in a map anymore. Nobody's interested in navigation anymore, because somebody else is navigating that. So we're at the brink of integrating public data, private data, seamlessly into a space navigation tool behind the scenes. Just like you have in your Google or in your Apple, you don't know what is in the black box that's collecting your position, what's silently giving information to Google which then in the end gives a cloud and says this is a busy place or not so busy place at this very moment.
Perfect. Vladimir, let's nevertheless look into the black box and technology where you see, because we still have some engineers here and we want to understand that. So what technology is really, will influence either better cost effective, or which areas you see from the technology will be the most popular? And I think you're working also on some, if I may.
When we talk about the technology around space debris removal issue, we should also look at what kind of issue it is. Because the space debris removal is a problem which is not a standalone, but it's connected to other things and actually is a consequence of other problem, a big problem, which is lack of servicing capabilities in space. That if we think where all debris we get from, so it's all satellites that are not in use anymore, most of the debris. And imagine if we had the same approach here on Earth for automotive industry or for planes. Imagine all the cars you have in Riyadh, after you run out of fuel, you have flat tire or even problems with transmission, you throw it away. How many cars and debris you would see around? But that's exactly the approach we're utilizing in space for decades. So if we want to fix this tremendous amount of debris we're creating, only eliminating the existing debris is definitely not enough. We should understand that this approach for servicing and reusability should come to our operations in orbit like we already did successfully on Earth. So nothing to invent here, but to utilize the same pretty fine working model. Because the case for operators, for example, where the money is in geostationary orbit, they will confirm that after you run out of fuel, still you have a fully functional satellite that can work if it would have resources, or imagine created with a modular architecture in mind, so you can upgrade the payload, you can refuel it, so it will work not like 10 years or 7 years, it can work up to 20, 25 years. So you will have not one satellite for this frame, not 3 satellites, but instead of 3, 4, only 1. So you will decrease at least 70% of potential debris, just with changing your mind and approach for that. And that's a use case and business case for investors to understand. Because creating servicing capabilities...
Investors will come later. This is you have to get approved.
You're creating a better offer for the customer, and that's who pays you. And that's how you create the business.
I like the idea we have that. So if you have a flat tire and if you do not repair it, then the government or somebody, agent, tows it away and belongs then to the agency. So that is a good approach. I think we should take that in license.
Flat tire is business opportunity for servicing company.
Yes.
That's a space debris is a business opportunity for servicing company in space. Not only a problem, but an opportunity.
Excellent. I like the discussion. And the audience, I pre-warn you, you're also allowed to have some questions after this session to the panel, because otherwise it's not interactive enough. So no more coffee if you do not get 3 questions at least, so that you are prepared and you know who is guilty or not guilty. But before we go to Kelly, and go back to the business model. Because you have a different view. You work with universities, you work with startup agency, so you have the eagle perspective. Where you see then the business, new business models and business cases which should be shared with us. We make it tough, I know.
That is the million-dollar question. I'm going to actually stay on the opportunistic track that you mentioned, because we obviously know it's a problem. Space debris is a problem. We wouldn't be here discussing it if it wasn't. I think what's really exciting about this moment in space is we are now having very serious conversations about a cislunar economy, really starting in low Earth orbit and moving out. And that obviously creates a lot of challenges, but also opportunities. And when you talk about business models, I think they are still being developed, but there are industries that we can look toward, and I'll get to that in a second. I think that, Kevin mentioned yesterday, when you look at the regulatory framework, because certainly any business model goes hand in hand with a government component, and it has to be flexible, it has to be iterative, it has to be agile, but really business models also have to be integrative. And this goes to what you were saying before, is that as we are moving toward this future, we know what the solution or the problems are, but we're betting on very probable hypotheses of what the market is going to evolve into. And so we really have to be able to look at solutions in a way that is going to make sense for the future. It's what Luke talked about in his piece this morning. And a lot of times with the space industry and the space market in particular, people obscure the fact that we actually have a stable market. So when we just talk about moonshots, people don't realize that there's already $546 billion of established industries. And so the market allows for stability, creativity, and risk to all coexist. And so when I talk to people about how to actually think about business models in the market, I point them to two other industries as examples. One is the cell phone industry, and the other is the aviation industry. And the reason for that is that those two other industries started with really heavy government involvement, then trended toward commercialization, then eventually became this infrastructure and backbone for new products, new services, and new engagement. And so the space industry is really at that middle piece of trending toward commercialization. So when we think about space debris and we think about all these other technologies, you do have to get nuanced very quickly, and there are very viable business cases now, such as data. But you could point to the cell phone industry about what they've used to evolve more of an iterative approach, and they are actually looking at a circular economy piece. And so instead of just putting out more cell phones, they're actually looking at more repair, design, refurbishment, interesting things of that model. But what I actually think is more of a pointing piece to it is there's this balance between ecological sustainability and then also what the consumer wants. And I think we're also getting that with the space debris problem, because sustainability and scalability has been a pervasive theme, and it's certainly what people want. But in the cell phone industry, consumers necessarily don't care about that. They just want the cheapest option. And so when you look about all these new nations that are going to be coming online, the United States, certainly as we saw in one of the charts, is responsible for more of the debris, but for others that just want to launch satellites, is sustainability really that much of a concern for them? So I think seeing how this business model plays out in the cell phone industry could give us some indications about how to tackle this problem. I think we're all solving it together, but it's to be determined.
I like with the other industry, I'll come to that later. And before Adam, I have to do some one commercial in between, because not everybody internationally is aware from my international guests. CST is not only the regulator for space, it's spectrum, telecom, IT and emerging technology, and space. So therefore, I like the cell phone example. Thank you so much giving me the pathways. Adam, now we do the recording. How the business model has to look like that you may invest.
That's a very good question. And obviously, VC is a kind of venture capitalist and investor which, on one hand, needs to be patient, but on the other hand, is obviously expecting extraordinary returns in the longer term. So it's the way of trying, to search for the companies which are not necessarily today already global leaders, but will be in 5 to 10 years' time. So it's like a kind of a trying to find out where the music is going to play in several years from now. So definitely, when we look at the companies, first we look at the founders, because we are betting on teams. We are betting on some of the most amazing founders with great minds, with unique ideas, with unique IP in their minds that can build something extraordinary again 5 to 10 years from now. So we really start from people. We start from great engineering teams. We start from people with passion and determination. So this is, I would say, the founding. And then we try to understand where the market is. And as mentioned, originally we're very much betting on different sensors for Earth observation, as we believed, and we still do, that to understand what's happening on Earth, you actually need to look from space. It's really hard to understand the trends. It's really hard to understand the dynamics of environment, of basically any major trends on Earth from within. So that's why you are using sensors, not only optical sensors, but radar, infrared, and so on, to, for instance, understand the hydration, to understand the plants, to understand the agriculture. However, frankly speaking, we started to invest. Most corporations were treating this data as a fun data. So we're saying, okay, give us some data, we can experiment, we can have a look, and nothing was coming out of this. It took far more than we expected to pick it up. Now we slowly start to see this happening. We slowly start to see insurance companies, food and agri companies. We start to see really global corporations making use of data. It takes time. It takes typically much longer than we expect, but right now we see the traction. And it was mentioned, like you cannot provide the corporate clients, you cannot provide the commercial clients with a raw data. Raw data is consumable by the governments, by the space agencies, and sometimes for the dual use, meaning for defense. These are the only clients that are capable of consuming raw data. For all the others, you really need to provide solutions. You really need to provide the actionable data that they can immediately plug to their systems and make use of it. And yeah, last but not least, like we believe the market is already saturated to a large extent in Earth observation. So the next trends that we are watching are the space infrastructure. We believe that's where the money will be flowing for the next years.
Space infrastructure services, and I would really like so one of the patient investors, at least within the time frame, which is not always there. And you're right, because I think it was Apollo 8 looking down around the moon, and then they were surprised to see the Earth. And then they rushed to get films with color. So it's the unexpressed. You have to see it, you have to tackle the problem. Without Earth observation, we will not even have climate change. I want to give the audience the chance. I don't know if we have microphones. Hopefully I pre-warned the people up front. So where are my volunteers to save the next coffee break? So, yes, very good, very much, perfect. We need a microphone. Right. Yes, tamam. And say when you work in one organization, who you are, what is the organization. A short question, one question, not two, one, that's perfect. And we need power on the mic. Yes. If not, in space we like redundancy, we need a second mic. If not, you have to speak up very loud.
Oh, it's good.
We hear you.
You do, okay. Hello. Yes, I have two questions, if you allow me. The first one is funny, so I will start with it. Maybe the debris are there for a reason, Just think about if it's not for asteroids, we wouldn't have existed in the first place because dinosaurs would have populated the planet. Okay, that's the funny question. But
was it a question or was it a statement?
It's
one question.
Okay, the question is, we are most concerned actually about the debris that we cannot track. Because the ones that we track, we can avoid it using maneuvering, especially with expensive assets. They can be equipped with maneuvering mechanisms to avoid the collision. But for the small debris, the untracked ones, there are billions of them, and it's very hard to remove them. It's impossible. There's no way to remove them, so we have to live with them.
Sir, I have to ask you the question.
And the question is, from the economic point of view, if the risk is within 1 in 5,000 of colliding with any of these objects, how would you make a business case out of this risk, very small risk?
So the question is, so we have a very small risk hidden by a debris which is hard to track.
From the economic measures.
Yes, so how we make a business out of it? Who wants to take that?
Although I'm not actually the one that is inventing the companies, so these are the great minds of the founders. From the market perspective, how I can answer is there is currently already like an annual spend of over 200 million on maneuvering in order to avoid the risk of being hit. So, and each and every maneuver is at least $1,000 US. Of course, it's an average one because it's different for International Space Station. It's a different one for a small sat. But overall, it's a market which is super dynamically growing, currently already, as mentioned, over 200 million. So how do you do business? You basically take the market which is already existing and you try to solve some of those issues. And if you know that those issues are going to grow exponentially, unfortunately, then you already know that this market is not going to be 200 million next year, but maybe twice this amount, maybe 3 times this amount, and definitely dynamically growing over the years. So yes, there is a market potential to, that needs to be resolved.
Kelly?
Yeah, I would actually flip that and say the risk, look at the risk of not investing in space. So when you talk about business models, you can't decouple risk. But to Adam's point, space is evolving whether we're on the train or not, and there's 102 countries now operating in space. And so the risk is not moving in and creating this infrastructure and then dealing with those situations, and those types of companies will be necessary for the proliferation within space and how we want to grow.
Perfect, and trust me, the people at Münchner Rück, they make money out of every risk. It's just a calculation. Another question, one more to go, and then we continue with our question.
Frank, but what about my perspective on that?
Thank you.
That's an important issue. Let me say.
Okay, Vladimir, fine, yeah. Please. And then we take the next question.
To the question, what to do with the debris which you cannot deorbit? And that's, I think, an important question to ask. Because if you want to do something with it, you should differentiate what is an asset in space and what is debris. Because the same satellite, while it's working for the purpose it was built, it's an asset. When it stops working, it's a debris, but it's still the same satellite with the same materials, resources behind it. So how we can utilize those resources to repurpose debris into asset again? And that's where also is a business opportunity. When the mic is not working, it's not an asset, it's a debris. You fix it, it's an asset again. With a satellite, it's the same. So when we figure out how we can repurpose assets, we'll be turning debris into assets again. We can create a fuel from all of that pieces of debris. We can repurpose old stages for new modules for space stations, you name it. There are a lot of creative applications. So repurposing debris into assets, I think that's the way to go and solving the issue we're asking about.
It's a good one. There's a nice company, I think Orbital Recycling goes also in that direction, taking the stuff. So we had one there. I saw that. Yes, when we have a second round in time, you will be part of it. If not, you get the first tickets lining up when we come down. So we have one question was there, and then we stay it until we close with our question, and then later I'll give the floor to the audience again.
Thank you, Frank. Oliver Menge from PwC. The technology aspect of space debris is very unique, but the business aspect maybe not so much, and you alluded to that. So I was wondering, are there any business models that we can learn from other places where we have littered as mankind? Oceans, forests, minefields, maybe?
Oliver, that's not fair, that's my question. So that's, but it's good, and let me see, we give that right. Rainer. Okay, what are other business models from other sectors we can adapt?
Well, I think it's probably first, where should you be fishing? I mean, we're somewhat in a sustainability business. Yeah, I think we can get inspiration along the sustainability industry. Yeah, from recycling business models where people make an asset out of junk. Yeah, take an example. For example, the printer cartridges. Yeah, printer cartridges. There are companies who even pay you for sending it there because they can make value out of that. Yeah. Equally, looking at how assets are being managed. I think we're moving from ownership to lease models, which open all kind of opportunities in this whole game. Then look at how immaterial assets can be traded, and I think modern stock exchanges and derivatives and so forth, they have shown that you can trade CO2 rights, you can have even fractional ownership of pieces, Bitcoin, blockchain enabled, and so forth. So I think there's lots of potential to look at other technologies in addition to the obvious suspects, oceans, deep ocean, robotics, and so forth.
So that brings me to Vladimir. When you say we take adopting other business models, so what would your dream partners as a startup?
That would be definitely companies who are now already working on assembly large structures in space. And the most expensive part to bring resources there to assemble something. But if you look around, you can get a lot of stuff already as a debris. So it's up to them to figure out how they can utilize it and what technology they need to develop to make it in a cost-efficient way and cost-efficient manner. And I think that will be a foundation, how all these debris, which are not planned to be removed, because I remember the insight from Luke regarding picking up the Russian debris as a good use case. I don't think it is so. So maybe we shouldn't pick up the debris for others, but instead to utilize it and build value on something which we think now is an issue. I think that's a big new opportunity for startups.
And then a little bit selfish, when you say, Frank, what are the 3 companies in the kingdom you want to partner related to this?
I think obviously we can start with Axiom regarding the servicing capabilities and assembly large structures based on the assets that you can get already in orbit. I think that can be a good use case and maybe a leadership that we can show to others.
Kelly, global perspective, just when you say, when we go already in that and saying other business model, other sectors, you have this overview where you would like to have partners which be part of the supply chain. What would be your first answer to that?
Everywhere.
Yeah, you have the global view. Space Foundation has the global view.
Yeah, well, I would say that it's necessary for everyone to be part of the equation, because really, as we look at these integrative business models, it is going to take the totality of the ecosystem to build this eventuality, because ultimately, we're talking about sustainability, but we're really talking about scalability. Because as I mentioned in the beginning, we are betting on a probable hypothesis, but we are building this future together, and so you need lots of different companies from different perspectives. Once we track and monitor, then when we actually build out this infrastructure in low Earth orbit, we're going to need robotics and refueling and energy storage and all of these other components that are going to be necessary to enable the next gen technologies to capture space debris. And so I think that the more people we can get oriented to the problem now, to have that discussion is relevant. But beyond the partners from a commercial perspective, I think we also need to bring government into the equation, because when we talk about scalable business models, and it was mentioned, Adam, actually from you, the governments are still the primary customer when it comes to space now. And so a lot of these new companies, when they enter the game, I always tell them that commercial alone is a myth. Because when you look at global governments, there's still an integrator, a demonstrator, an investor. And so governments do have a part to play to potentially prove out these business models to also drive down costs, so there is more of a commercial opportunity.
Yeah, we just launched, I think, November, the space market report for the KSA, and then we say the global market, 12% is the upstream, 88% is the downstream. I agree for the upstream segment. The downstream, I think, is the big space potential. Adam, I'm sorry that I have 1,000 questions, but we have to be more attractive. What is on the radar list? But I think we do not share your secret. But when you look into that perspective, when you invested in ClearSpace, it's pretty unnormal that the investor takes this leapfrogging. So what you would like to see when we go to be more attractive in this supply chain? That because you have partners, you do some deals you don't do alone, what you would be as a wish list comes from other investors, even corporate investors?
So I believe, that our investment in ClearSpace is a real well thought out investment, because we see a huge opportunity to build a whole ecosystem around ClearSpace, and maybe also a bit referring to the question that was asked a second ago. We talk about space logistics, yeah, and then when we are talking to also other investors that've never been investing in space before, we are trying to draw them the picture of similarities of how the space ecosystem is going to look like, comparing it actually to the logistics industry on Earth. It's all interlinked, it's all interrelated. If you've got the International Space Station, or if you want to build a hotel in space, you need to have all the logistics. You need to have a docking mechanism, so you need to reach out to Course Orbital. You need to have refueling. You need to have the capability of grabbing waste, but not only waste. I can very well imagine ClearSpace capturing different assets and bringing them downstairs, bringing them to Earth, including, like rare resources in meteorites. So of course, it is a distant future, but you need to start with something, and then you need to build step by step. So it's hard to imagine investing in a company that is going to start mining on Mars today, because the vision is obviously super interesting, but then you don't want to invest in a company that will show you some revenues in 2045. Yeah? It's uninvestable. But if you can find the companies that can start generating the revenues in 3, 4, 5 years, and then growing, and then expanding, and you see, okay, then you can go into this direction or that direction, then it's much easier to invest. And again, coming back a bit to your question, like we are probably today the most active space tech European investor. So we are trying to bring a lot of other VCs to invest along us. And originally, we need to tell them the story that they want to believe and they are capable of imagining, and it takes, and it's not easy. So typically after a year or two, once they start investing with us, they actually start to get excited about it. And obviously, everyone would be most excited about rocket launchers. We are not really recommending investing in this space that much, but everyone wants to have a rocket launcher, just like every private equity company wanted to have a TV station or an airline back 10 or 20 years ago, because it's just very sexy. But we believe the real money is in the infrastructure. The real money is in this interconnected world that will need several companies to cooperate, bring their innovations, and then make this ecosystem in space quite similar to what we see today in shipping, in freight, or in any other logistical part of the industry.
Yeah, thank you so much. And I remember Luke said, okay, this is a sector which needs more service. And we all know that in service, normally you really can make an honest buck. Thank you so much. And for all the investors in the audience, speak with Adam. If you do not trust what I'm saying, that this is the right market to invest, which I'm preaching for the last over 20 years, maybe you listen to people which put own resources and budget and funding into it. We still have a little bit of time. I've seen that colleagues were so generously adding another 10 minutes to our session, and there was one lady which was still here, and a gentleman. First we do the lady, and then the gentleman. One question, short. Please say who you are, for whom you're working, so that it's easier for the panel to answer. So if we can give the mic first to the lady, and then to this young gentleman.
Hello, my name is Azal Yamini, and I'm from Egypt, and I'm a CEO of Dual Launch Company, or startup. We have been working on designing a mechanical subsystem for the orbiting CubeSats after they finishing their active life in the orbits. So I'm asking you gentlemen about the resources or support you're talking about for startup programs.
So I cannot, for startup programs...
You were talking about the foundation yes. of supporting startups who are interested in space debris.
So before you, the audience, so of course I cannot speak for Egypt. The head of the Egyptian Space Agency was here. I'm not sure if he's still around. So for Egypt would be the right one. I can answer it for the Kingdom of Saudi Arabia. So we have an Office of Entrepreneurship. We have a soft landing program. We'll be starting the first initiatives, but maybe what you need really should be also answered by an entrepreneur, and I give it to Vladimir because he's in that situation. What are the three major components you always would love to have as a startup?
I think basically speaking, for any ecosystem, it's very important to build this whole pipeline for a startup. When you come up with an idea with your team, then you can have resources to validate it. Then you proceed with some kind of incubation programs, so you can feel the market fit, to talk to the stakeholders. Then you proceed to the acceleration programs, where you actually start building the product and testing the market, having first use cases, getting LOI, signing MOUs, and then you have the VC ecosystem with a pre-seed, the seed level investment, which you can acquire resources and get to the market faster with better products. And I think that building this from step one to the step I just mentioned, that's actually what governments can provide for their ecosystem, and that's what we see here in Saudi Arabia with the support of Frank and CST and Saudi Space Agency. So building this vibrant ecosystem will be a platform for startups to evolve, not only for the local teams, but also attracting brightest minds and talents from all over the world. And I think for the segment we're discussing today, with the space debris removal and servicing capabilities, that's a way of leadership that Saudi Arabia and its ecosystem can show to the world, and that can be their gift to the global space industry.
Perfect, thank you so much. Last question, and one of the audience with a short answer on the time. We need the microphone to the gentleman.
Hello, my name is Saleh Battiur. I am a physics student at King Saud University. I don't know if the opportunities in the space business differ from one country to another, depending on the climate, latitude, or any other factors.
Who wants to take this one?
Well, I mean, if you look at space, you can complement, yeah? I think the space business is a global business, but it does have its regional subtleties, yes? Obviously, dependent on how far you go into the dual use, you have geopolitical complications, dependent on how much you need the proximity of hardware players. You might have different requirements and you might have different opportunities. But overall, I think the world is open in this whole world, and the more it becomes IT, the more it becomes services, you can do it pretty much from anywhere.
Very good.
And I'll just add, I think you mentioned Earth observation. I believe that's what you said. One thing I'll mention, and it's been talked about yesterday and I think a bit this morning, but the downstream and upstream effects of space business. So when you actually look at the economics, so the 546 billion, 78% of that is commercial, and that's really broken into two subsections. It's things that enable space and things that are enabled by space. So we call it the space to Earth market, and that actually is 2/3 of it. So utilizing space-based data, tech transfer, better processes, subcomponents really does enable other industries within localities. And so you don't necessarily have to just develop a rocket or a satellite, but you can utilize space for life on Earth in these adjacent industries that are very much viable and part of the space economy.
Thank you so much. I have a good tradition to close the sessions. Always, I start a sentence and the audience are not aware how the sentence will start. So this is all live, because otherwise it's not attractive. You see they're already starting being scared. That's very good. So I start a sentence and you have to find a proper ending which makes sense. So, and Adam, you have to be first, first mover advantage as usual. By the year 2040, my company has invested in 5 service space companies because of?
In 2040, the companies that I invested will...
No, so by the year 2000, we'll make it shorter, 35, we have invested in 5 space service companies because of?
Okay, sure, that's easy. Because of their unique competence in providing the space logistics in the area of definitely space debris, and one of them being clear space.
Very good.
But no, seriously speaking, I believe we want to go more into the area of in-space manufacturing, because we believe...
Just close the sentence.
Okay.
It's good. Adam, it's fine. It's fine. Kelly, Space AAA. You know AAA, the towing service company in America, when you have a flat tire on the street? So, Space AAA was founded in the year?
2029.
Very good, we write that down. That's I really love. So, okay, it's a good, another business model opportunity where you can make money. Vladimir, in the year 2030, the biggest space service company is doing
the same it promises to do today.
He was trained, he was trained. He gets an applause, he gets an applause. That's very good. I like that.
Okay.
Okay, Rainer, so I have to make it tougher for you, I see that. We will have 100 new space service companies in the ecosystem by the year
2028 already?
2028. Thank you so much for the panel. I think the panel gets applause. I should be next time harder. Thank you so much for being with us. The applause is yours. Take your chance. Yes, one question. We have one question. Okay, we are very kind. A last question, even when the panel is over. That's good. Yeah. Have you contributed to contribution to the panel? No? That's okay. Please go ahead.
Oh, thank you for the opportunity. And my name is Noor Al-Muhayzi, and I'm a fresh graduate from King Saud University. I'm a physicist. But my question is today, so since we're talking about new innovation solutions, and we're talking about technically, after talking about regulations yesterday and policies, and we're talking about bring it back home. Especially in this panel, we're talking about the hidden opportunities in plain sight. So why not, we have our assets, right? And we're talking about a challenge, I wouldn't say a problem. Why is that? Because why not take the space debris and convert it into an asset again? Especially we're talking about a golden age in space. I mean, we have
That's a brilliant idea.
Vladimir, I think this is your question, because that's exactly what you said.
I will write it down. That's a brilliant idea. We should all listen to it and follow this idea.
Okay. First, I think great is you studied the right thing, and we are very proud to have you. And I think this is why we are also here making out of ideas companies and dreams come true. So we take that. Also, this young lady gets an applause.
Thank you.
And I think after the session, you want to have a longer answer? No.
No, I just wanted to...
So I'm just checking, you know, responding with the clients. So after the session, grab Vladimir and the panel and continue this idea. Perfect. Thank you so much for staying with us. We are not done today. You still have some good sessions. After us, thank you for being with us, and enjoy the rest of the show.
Thank you for such a lovely session and great moderating. It was quite fun, including the audience as well. So we thank our dear audience for their participation into this panel. Now, ladies and gentlemen, we'll take a quick break and we will be back here at 3:10. So please gather back in the conference area, 3:10. Dear guests, we will be back at the conference area by 3:30. Please have the time to make your prayers if you wish, and we'll meet back at the conference room at 3:30. Welcome back, ladies and gentlemen. I hope you enjoyed that stretch and the break and you had a chance to stretch your legs, pray, have a snack, and be back energetic and excited for the next keynote that we have coming up. So as we are near the conclusion of our conference, we are privileged to have the co-founder and CEO of Axiom share his experience with us in this following keynote address titled Space Debris, Today and the Opportunities of Tomorrow. So please, without further ado, welcome on stage Michael Safardine, Axiom co-founder and CEO.
Good afternoon. It's a quiet crowd, I can tell. I'll try not to wake you up too much. So I come from a history that's a little different than most of what we've talked about here at the Debris Conference, but although the spacecraft is several orders of magnitude larger than what most satellites are, the issues are still the same. So I, as the ISS program manager from 2005 to 2015, before I became the head of Axiom Space, and during my tenure, there was a movie that some of you may recall called Gravity. You guys familiar with the movie? If you're not, you need to go see it. You should see it on the screen about that big, and you'll be excited and energized by the end of the movie, not because of the great things that happen, but just because of the excitement around what goes on in the movie. But the movie is about orbital debris and the calamity associated with that befell the crew in that movie. And while the movie is fun, orbital mechanics are a little sketchy, but the movie is fun. The issue is very real and really not that much fun, especially when you're talking about humans in space inside these space stations. So I retired in 2015. There were roughly 20,000 trackable objects in Earth orbit, and by trackable I mean 10 centimeters. You heard everybody talk about today, roughly the 10 centimeter area you can track. So today that number's doubled already since 2015. So there's about 44,000 objects. 9,000 of those are operational spacecraft, give or take. So you can kind of get the idea. Now between 1 centimeter and 10 centimeters, and I'll tell you about what 1 centimeter means to us here in a minute, there's about 500,000 objects. And from 1 millimeter and above, it's something on the order of 100 million particles. So it's a pretty nasty environment out there. Some areas are worse than others, but still it's a significantly challenging environment. Worthy of note, as the objects get smaller, they found in some of the debris models, you end up with small stainless steel beads. So you can imagine the mass of that is not insignificant. And a 3 millimeter particle, roughly a solid particle, is about the energy of 2,000 joules. So imagine a bullet from a rifle is about the same. So very, very small objects can have very, very large impacts to you. The good news is that the ISS itself and the Axiom Commercial Space Station, the first module, which launches in the fourth quarter of 2026, have a few lines of defense to protect them from debris. The first, of course, is the orbit. We sit in a 400-kilometer orbit, whereas the greatest concentration of debris today is between 750 and 1,100 kilometers. So by choosing 400 kilometers, which, by the way, originally when the ISS orbit was determined, it didn't have much to do with debris. It mostly had to do with radiation and performance of the spacecraft taking hardware up to ISS. But over the years, debris has become a bigger factor as we've managed around that 400-kilometer range. But at 400 kilometers, that reduces our risk factor by about 12. The second line of defense is simply getting out of the way. Again, we talked about this. We said whenever there's a 1 in 10,000 chance that debris greater than 10 centimeters has a chance to strike the ISS, we perform a collision avoidance maneuver. 32 of those have been performed since 1999. 50% of those have occurred since 2014. And when the crew doesn't have enough notice, which happens from time to time, then they have to go get into their escape capsule. There's a spacecraft on board when the crew's there, and they get in the spacecraft and close them and get ready just in case the vehicle does get struck. Based on NASA's report, and this is significant for all satellites, each time that we've had to do the maneuver, it cost us about $1 million in prop and the crew time it takes away for configuring everything to do the maneuver. The third and final line of defense is debris shielding, actually. The debris shields on ISS can protect the ISS in most cases for an object at least a centimeter size, actually a little larger in some areas. Shielding on the ISS consists of multi-layer insulation, Kevlar, ranging from 10 to 13 centimeters in thickness. The shielding is typically thickest on the front and sides of the station, the front being defined as in the velocity vector. The shielding mass, though, and this is another big factor, the shielding mass is 22,700 kilograms, which given the total mass of ISS at about 450 metric tons means about 5% of the mass. So it has to be heavier by 5% just to protect with the shielding. So just as an indication of how real this threat is, one of the panels earlier talked about this. The ISS has experienced quite a few impacts. The first elements were launched in 1998. A number of impacts have been observed by crews during spacewalks and via external camera views. However, the best example are two MMOD shielding panels, these two objects you see up here on this screen, which spent about 8 years on orbit attached to the airlock module. It was brought home from Earth and inspected. It had 58 impacts on just those two panels, 8 years in orbit, and it wasn't even the worst part. Those were actually in some shielded areas around the airlock, 58 impacts. So you can see that if anybody's questioning whether this is a real issue, those panels alone would tell you that. There are a number of other instances. We used to take a spacecraft up. The space shuttle used to bring a pressurized module up. It had all kinds of hardware and crew supplies. We called it the MPLM. We would pull that off and attach it to the ISS and stay there for about a week to 14 days and come home. One of those came back, had 2 holes in the shields. The underneath Kevlar panels absorbed the impact, and we didn't damage the pressure shell, but we actually had holes in the shield. So it's a nasty environment out there. The largest observed damage on the ISS to date is a puncture in a radiator panel. The damage shown here is the exit side. The entrance side, of course, is a little bit smaller, as you would expect. This panel is a thick honeycomb panel that contains many coolant tubes. Fortunately, in this case, we didn't end up ever striking the tubes. So it's just a bad environment, and if there's any question to that, you can just tell by the images that it's a very real thing to be concerned about. The Axiom Commercial Space Station, which is in the image here, is being designed with all the lessons learned, and as well as upgraded shielding to protect this first commercial space station. And really the question for all of us is that really enough? Our vision is ambitious. A city in orbit by 2050 with over 200 people on board from around the globe living and working in space, supporting the Saudi Space Agency and other countries and their agencies to establish and build space exploration programs with LEO as a foundation, Moon and Mars as destinations, working on orbit spacecraft yards to assemble 100-meter class human-rated vessels to transport astronauts to LEO, from LEO to Mars and beyond, working on factories leveraging microgravity to manufacture pharmaceuticals, artificial organs, biotechnology, semiconductors, and advanced materials. To realize this vision and to truly unlock the multi-trillion-dollar space-based economy, we must collectively do more to address the space debris problem, or we may find ourselves trapped here on the surface without the advancements and benefits to humanity that microgravity environment offers. There's a tremendous opportunity at stake here if we don't take a proactive approach to this vastly mitigating the space debris problem. There are a number of solutions to the space debris problem. Many have been discussed here at SDC. I put them in 3 categories: regulations and law to require launch providers and satellite operators to prevent debris in the first place, domain awareness, space domain awareness, so that we can better understand, track, and manage traffic to prevent debris events, and finally, debris removal. Today, due to the tremendous work of the UN, Office of Outer Space Affairs, there are the Space Debris Mitigation Guidelines, which were adopted in 2007, and the Compendium of Space Debris Mitigation Standards. There are best practices provided by the U.S. government, being the Space Policy Directive 3, which was released in 2019. There are regulations either in place or being deliberated on by regulatory agencies around the world. And while these are necessary steps, now we must have a coordinated effort between spacefaring nations to develop and enforce laws that require preventative steps by developers and operators. This is the only way to drive known best practices into design and operation. Best practices, regulations, and laws are necessary to stem the generation of new space debris. However, more must be done to eliminate existing debris fields. Better space domain awareness provides operators the best chance to avoid debris-producing conjunctions, not to mention loss of satellite function. Today, technically, the tracking systems in use are said to track objects at 10 centimeters and larger. This statement implies an accuracy that is misleading. A 10-centimeter cubed object can be tracked consistently, but oblong objects, say 1 by 14 centimeters, may not be able to be tracked accurately and provide a state vector necessary to really know where the object is. So you heard another panel talk today about their object, tracking their object, and with two hits, they could get within 100 meters, 30 meters, I think they said, with 2 hits. That sounds really, really good, but 30 meters is the difference between an impact and not impact, and you don't know which way that works. So today, we do our best job of tracking objects. Objects that aren't well-defined, a well-defined 10-centimeter cubed object may not be able to be tracked. And these oblong objects are as dangerous as any other object that's out there. So in the case of the ISS, an Axiom commercial station, we are shielded for debris from 1 centimeter, and we can maneuver from objects 10 centimeters or greater. But an object in between can be catastrophic for the station and crew, and we really don't have a defense against that. By the time I retired, we were estimating roughly 1 in 100 chance of an impact in a 6-month period that would cause loss of pressure, which, of course, as you know, can cause loss of crew depending on how big that is. I don't need to tell you that this is a significant risk. With better awareness of where the space debris is, and with better resolution of space debris smaller than 10 centimeters, risk of collision and damages can be mitigated further. The ability to resolve down to 1 centimeter or smaller would be a tremendous development for the protection of space-based assets in Earth orbit. Advancements in space awareness, traffic management, the advent of space-based domain awareness assets currently being developed in conjunction with ground-based RF and optical observation capabilities, which you heard about earlier today, are projected to be able to resolve objects down to 1 centimeter, increase our ability to move away or shield from the vast majority of the threats. But no one system is going to do that for us. We really need a combination of systems working together. But to completely win the war against space debris, we must be proactive and deploy active debris removal systems. There's no one debris removal solution out there that will resolve the problem completely. On Earth, we have garbage bins, garbage trucks, recycling plants, landfills, entire ecosystem of capabilities and infrastructure for waste management. We need the same infrastructure robustness on orbit. Robotic capture capabilities in vehicles, space tugs, designated debris depots, even orbital debris repurposing facilities. However, these capabilities will be slow to develop and deploy because there's no clear business case. We hear a lot about what commercial industry can do, but the foundation of that is that it's going to eventually make money. And in this case, it's kind of hard to see where the money's going to come from. LEO platforms such as ISS and the Axiom Commercial Space Station and other large-scale infrastructure are necessary if we are to unlock the microgravity trillion-based trillion-dollar space economy that will benefit us all. Therefore, reasonable and customary countries can bear the cost and should bear the cost that will benefit the whole community. Countries who have benefited the most and those who have been perhaps responsible for unnecessary and irresponsible debris-generating acts should bear the largest cost to remediate. In addition, as a space station developer myself, I believe it's reasonable for those of us who use Earth orbit for financial benefit to help cover the cost as well in the form of taxes. In addition, as we mentioned during the first panel yesterday, active debris removal capabilities and the infrastructure can take advantage of the same robotic capabilities in vehicles that are envisioned for servicing and refueling satellites, moving payloads to different orbits, and eventually servicing and assembling large space infrastructure like future space stations, Mars-bound spacecraft, and our own city in space. This synergy will significantly reduce the debris removal costs. I don't think I've been keeping up with myself. Those are the three. All righty. The space industry is an ecosystem. Axiom Station, in a way, is being developed as a reflection of the diverse ecosystem of capabilities and stakeholders that it means to support. We believe in the interconnectedness of the ecosystem. The more interconnected and multi-use we architect the ecosystem to be, the more likely we are to succeed in solving the debris problem and growing a sustainable global space economy. On this slide are examples of how we envision using the Axiom Station to support active debris removal solutions by the end of the decade and beyond. On the left is a description of how the Axiom Station will be used as a staging point and/or a refuel and repair depot for active debris removal spacecraft. Most mission architectures involve single-use spacecraft that are destroyed after they succeed in deorbiting a large object. The Axiom Station produces, as a byproduct of its life support system, oxygen and methane, which can be used to refuel orbital debris spacecraft in orbit, potentially permitting multiple use and reducing both CapEx and OpEx costs associated with those spacecraft. On the right side is a description of Axiom Station's orbital data center, commodities distribution hub, and perhaps most importantly, recycling depot. The orbital data center, which we are planning to deploy into the station's first module in 2026, could be connected to space-based domain awareness satellites and their sensors via high-speed optical communications link. The benefit of that connection would be to offer space-based domain awareness spacecraft the ability to offload their data for post-processing in orbit using artificial intelligence and machine learning capabilities residing on the data center. This facilitates much faster processing of sensor data, resulting in more accurate tracking of conjunction events and with higher resolution. Lastly, space debris recycling is another opportunity area to repurpose debris and extract additional economic value. You heard that at the last panel as well. Companies exist today that are developing furnaces for operation in low Earth orbit and the lunar surface with the purpose of smelting space debris into reusable materials like metal bars for in-space construction, or solid fuel stock for plasma-based propulsion systems. Axiom Space, in conjunction with the ISS National Lab, is supporting cislunar industries with the demonstration of a prototype foundry on ISS to smelt simulant space debris material. We envision that such furnace capabilities could reside in the Axiom Station to further enhance the economic value of active debris removal systems. Let me close with this. Space debris is a clear and present danger to us all and has some serious implication on design and operation of space station. These huge multi-purpose spacecraft must be protected not only because of the concentration of multiple industries on one platform, but more importantly for the safety of the crew that reside within. However, due to the advancements in technologies, awareness, thanks to conferences like this, I remain hopeful that ongoing developments in best practices, regulations, laws, space domain awareness and traffic management, and deployment of innovative active debris solutions will all culminate by the end of this decade towards a holistic and sustainable solution to the space debris problem. Axiom Space looks forward to working with all of you on securing the future growth of the global space economy. Thank you guys very much.
Thank you, Mr. Safardini. Now, after gaining invaluable insight from Michael Safardini's keynote address on the current state and future prospect of space debris management, we now turn our attention to our final panel for today, where experts will discuss strategies for turning the tide on orbital rubble, aiming to explore actionable solutions and collaborative efforts. So please, without further ado, put your hands together for our moderator and panelists for this final session. And dear panelists, please take your seats under your pictures.
Dear all, last day, last panel. We're going to talk about turning the tide on orbital debris. So I'm Harald Luijks. I'm a team lead in the satellite engineering team within the Saudi Space Agency. And I would like to do a little survey, if I may. Who can still hear the words space debris after talking about it for 2 days? Can I see some hands? Okay. I think there's some people who fell asleep. Okay, now it's... So I can convince you that this will be a different panel. So here we're going to talk about big ideas, the far future. And I got a really nice team here to help me with that, to discuss this. And one note before we do the introductions to the panelists. You're completely free to disagree with each other. It's also okay to not echo and to not say that you agree. It's fine, I already just wanted to say that. So let me dive in and I'll leave my panelists to introduce themselves. I'll start with Amy here.
Thank you. So I'm Amy Melman. I'm Vice President for Global Affairs and Stakeholder Relations at eSpace. eSpace is a company that's going to be launching a series of satellites in low Earth orbit, mostly focusing on IoT services. Our goal is really wrapped around sustainability. Our ideas as far as designing, launching, and operating our satellites are really around this idea of sustainability. And of course, the applications that we're looking to provide here on Earth are also around efficiencies and making sure that we are creating a better environment here on Earth in the future. So
thank you. Thank you for introducing yourself. Dan, please.
Yes, Daniel Faber, CEO of OrbitFab. OrbitFab exists to create a bustling space economy. We want to see an economy in orbit that can support permanent jobs in space. Our part of that, our mission, is to be the chemicals supplier, a petrochemicals company in space. So we're looking right now at storage, distribution, logistics, providing fuel to various customers in orbit. That, of course, includes companies that want to do active debris removal, that want to do something about space, companies that need to move around in order to see debris and keep an eye on things in space. But we are moving beyond there into refineries and into using the resources that are in space to create that economy. So that's our big vision.
You, Claire, please.
Hi and welcome to Lunarville. For those of you by now, I'm sure you all know, I've heard about Bob Marley. Well, I'm from Jamaica, and I was the first Jamaican on the moon back in 2038 when we went to set up the Lunarville Heritage Site, that's human heritage on the moon. But perhaps I've gone too far in the future, so I'll probably come back to 2024, where some of it began in Ridai, and to say that back then, I was only a futurist at the Futures Forum, a nonprofit research and education practice I started. And in doing that, I also started a community of practice called the Space Futures Forum in the middle of the pandemic. Out of that has come two things: the Caribbean Space Society, which involves 3 universities in the Caribbean, 3 students' clubs, because as it is, most presidents have said, nobody in my school believed that I should be doing space, so that's where we started. And on the other side of the pond, Atlantic, we're doing OASIS, Omni-Africa Space Exploration Analog Simulation, and it's intended to be the first African site for analog research on space settlement.
And this last but not least.
Well, that's just beautiful. Thank you so much for sharing that. So I believe that every one of us has a responsibility to make life on Earth and in the universe better. And so when I was 5 years old, in 1957, I received a toy Sputnik with Santa Claus inside to put on the Christmas tree. And from that time on, I was absolutely convinced that everything good came from space, and I still do believe that. I kind of describe my very, very lucky life as using first space to provide universal access, like I spoke about yesterday, to then using space to access the universe. And now, following a little bit on Claire's wonderful vision, I'm focusing on building networks for the universe, combining deep space, near space, and our planet to serve life on Earth.
Thank you, Candice. So I think if we look at the past 2 days, I think we realize that as a space industry, we have to change. We have to change the way we operate. We have to change the way how we work. But maybe also how we view space debris and space assets. So I just wanted to ask the question, can we envision a future where space debris is not just controlled, but used as a resource? This is something which we have discussed in previous panels and keynotes as well. But this is a question which I wanted to give to Dan first, because he's working on in-orbit refueling.
Yeah, I'm going to take a completely different tack, though. How many people in the audience are artists? How many people appreciate art? So I have a great use for space debris. I think we have a solution, and this was suggested by a colleague once. I have a proposal, and for those that can follow the orbital mechanics and math, you might appreciate this. We should launch a large collection of very small tungsten balls into an equatorial retrograde orbit, elliptical between 600 and 1400 kilometers, nice small balls. They will grind down the space debris, and over the next 2,000 years, it will all re-enter the atmosphere. The great thing, though, is for 2,000 years, we'll have a ring. And I love the Earth, and as Beyonce said, if you like it, you really should put a ring on it. So this is my solution to space debris.
Perfect.
Well, actually, for some reason, what comes up for me is the Borg. Those of you who are Star Trek fans, imagine this thing grinding through space with just this mechanical voice. And I'm thinking that perhaps at some point in the future, we'll have a new form of an ISS, except it will be a recycling center. And I think it should be named after some god of reincarnation of some maybe lost tribe. And it will represent a new way of humans working together, because this will come about because of the convergence of so many different technologies in place now. I mean, there are people working on magnetic propulsion. There are people working on space-based solar power. There are people working on new indices and metrics. And even that makes a difference, because the space debris problem, as we know, is not really just a technological problem. It's a social problem. It's a political problem. It's a spiritual problem. It has to do with how we see the future. And when we can begin to imagine a future where we don't see that picture with all this debris floating around anymore, if we first of all can start drawing it, right? And that ring, maybe this big Borg floating around, where we can actually be doing that sort of recycling because of the convergence of all these technologies, 3D printing, aluminum smelting in space, et cetera, et cetera. So it's possible. I don't have a time for it, but I think it's possible.
So you're basically saying that we can also expand the scope of this discussion around orbital debris.
Yes, definitely. We have to go beyond the technology. We've spent a lot of time on technology on this session, but I think one of the earlier speakers yesterday talked about the fact it's not really just a technological problem. And so my solution focuses around creating a global space futures collaboratory, where we bring together this conversation in a transdisciplinary way, transnational, transsectoral, so everybody's at the table, industry, academic, stakeholders like myself, who I call myself representing the 99% of people who have no power, right? So all of us are in the room, because after all, space belongs to all of us. And if the worst case scenario happens, or the status quo scenario happens, we're all going to be toast or roast, depending on what side of the moon you're on.
Well, very well put, very well put. Amy, so you worked at multiple companies with a great number of space assets. So do you see opportunities for this, for this different way of thinking, of seeing it as a resource, basically?
Absolutely. I mean, first of all, there's been many panels. The last panel has talked about this. I think actually the panel before that, talking about the financial aspect, you see these impact funds that are raising billions of dollars to look at these various ecosystems that are being created around recycling in space, recycling on Earth, and finding ways to do more with less as well. But this sort of cyclical space economy, I think, or circular space economy, I think is here to stay. And I think the challenge will be, you know, how to do this not only in the geostationary orbits that I think you're working on, but really getting down to some of the lower orbits and figuring out how we maintain some of these assets over time, how we, you know, create less of a negative impact over time. But I absolutely think we can harness these technologies, and I think they're here. I mean, I really do think they're here already.
So you see also that the big companies are willing to adopt this?
Absolutely. I mean, look, at the end of the day, this is going to be about, you know, a return on innovation, a return on investment, and the positive impact that they're seeing and they're creating in the market impact as a whole. So absolutely, I think, again, you see this with some of the players in space already, the reusable rockets, right? That is very attractive. It's bringing down launch costs. So there's certainly the impact that you're seeing today, and those are the lessons learned that allow for additional investment in these types of technologies. So absolutely, I think, you know, large, medium, small businesses like ours so far hopefully will be big at some point, but absolutely, we're certainly looking at new innovative solutions.
Candice, what do you think about this?
Well, you know, I said I was an incredibly lucky person, and I really am. My father worked on the first satellites for the United States government when he was at the White House under President Kennedy and President Johnson. And then he did the first private satellite system in the world, Western Union, Westar. And so I grew up with, you know, Werner von Braun, Vint Cerf, the founder of Northrop Grumman, you name it, they were all at the house, and we got to listen to their stories. And in 1984, one of my father's satellites was launched into an unusable orbit. So Westar number 6 and the Palapa were launched into an unusable orbit. They were geostationaries. And my dad called on a friend who is also still one of my friends, about a 90-year-old gentleman, Del Smith, one of the great space lawyers, to say, hey, you know, what can we do about this? And Del convinced NASA, Hughes, the owners of the satellites, the insurers, Lloyd's of London, to hire the space shuttle, to use the robotic arm that NASA had developed, to train the astronauts to go and to get those 2 satellites, to put them into the shuttle, to bring them down to Earth, to refurbish them, and to resell them. This was 40 years ago. And so, you know, what happened, of course, is that the shuttle could no longer be used after that. But we already had people who were thinking about retrieving, refurbishing, and basically, you know, reselling. So, and, you know, the insurers, instead of having to pay out $180 million per satellite to the shareholder, to the owners, they the whole deal was done for $5 million, and they recouped their money, and also the shareholder, the satellite operators did. I want to give you a second thought, and this is something I feel very strongly about, because ever since we've been talking about, primarily through Dan, you know, about refueling satellites in orbit and in orbit servicing. I'm a big fan. You know, I've done Iridium, I did LEOs, I've done MEOs, I've done GEOs. I am a big fan of GEOs, and I believe that, you know, with the in-service orbiting, in-orbit servicing, that we will be able to refuel, and to also with in-orbit manufacturing, robotics, 3D printing, that we will be able to use the geostationary satellites as a platform for putting new payloads on, for doing deep exploration, etc. So not prolonging life, but giving a second life to those big investments that we did with the geo satellites. So I am totally with everybody here who says, no space debris, reuse every single thing that we can.
That's really interesting. Before organizing this conference, I never heard about this story. Because if you think about it, this is really a success story. The retrieval of these satellites and even reselling them and launching them again and using them afterwards.
Before you go on, just to say, I never heard that story either, so that story should be made more popular. Because in fact, it's the stories like this that we hear, that we share, that we must propel us to thinking critically about the future we want. If we're talking about a circular space economy, and there are many people pushing for a charter for the circular space economy, the idea would be to have satellite operators and owners sign on to this charter, recognizing that it has a lot of value. So maybe that's one specific roadmap. We're talking about a roadmap, and so we want to leave here with some action items, if you will. That could be one item. How can we expand this conversation on a charter for a circular space economy, get people talking about it, make sure it's on every agenda of every international space conference, begin to create a conversation that people like the young people in Space Generation Council now begin to talk about it and create almost like a social license to operate for these companies. So everybody has a phone, know it's coming from a satellite, they become the watchdog. We don't necessarily need the government. We can use these younger people, younger minds who are concerned about natural resources, depletion, and all those other things that the world has to contend with.
Yeah, that's actually, I think there is also an ethical aspect of this problem. So one question that I want to ask you, Claire, is do you think we are ensuring that we're making the right decisions for future generations? And maybe more specifically, are we focusing on the right issues?
That is the thing, future generations. I think we've just now become, as a human family, concerned about the fact that because of climate change and because of movements like Earth Overshoot Day, that we really are on the cusp. And I think pandemic brought it all home to all of us that we really are an interdependent species struggling for survival on this beautiful blue marble called Earth. And so when we look at the fact that the UN is having the Future Summit in September, right? And I understand the SJC was able to put space on the agenda. I think we now can hopefully see coming out of that more conversations. So futurists are not going to be just like this secret club that a few people belong to, but futures literacy will begin to take hold of in all these conversations. More importantly, we have organizations like the Wales Futures Generation Commission that has been studied by many organizations, many countries are looking at it, and I do believe we're getting to the point where we begin to see this paradigm shift into flourishing futures or zoetic futures. And I want to put that word out there as well. All of us want a future where there's a safe, just space for humanity within the 9 planetary boundaries that exist, and also that space between that which we said no human should live below this level of dignity. What we also want, that means we need a safe, just space for space, right? We cannot do without space. And so I think there is opportunity for us to make those decisions that, again, we need a decision-making collaboratory.
Yeah.
It can't be East versus West and global, North versus global, South and industry versus, street activists. We really have to make a space. And I do commend the Saudi Space Agency for beginning this conversation. I would like to see us leave here, not just as a conference attendee, but I want to see us make a move towards creating a community of practice around space debris, and the operational word is community. Yeah. Where we make the space for creating a shared story, hearing from stories, having that intergenerational conversation between the techies and the trekkies and all the different spaces to create this vision, first of all, the story of what an aspirational future without space debris looks like. And then we might find different ways to get there, but at least we'll have something we agree that we want to achieve.
So then, as a techie, if I can describe you as a techie, how do you take ethics into play in your role in this problem? in building the technology and in building this aspect of the future?
Yeah, I'll admit they threw me out of the lab a while ago. Now I chase investment and customers and business. But I was an engineer, at least for a decade or two, and built a bunch of satellites. And now I get to direct people building technologies for our refueling architecture and the like. The technology, though, is not there for technology's sake. The technology is there to serve a business purpose or an objective that's set by those that have the funding, right? And if that's not a return on investment, then it's an investment in science technology or something like that. In this case, we're talking about an investment in safety, an investment in our access to space. That's a possible tragedy of the commons that needs to be overcome. So how do you set the trajectory for that, the goals for that technology development? How do you commandeer the resources that are necessary for that? That matters a lot more to me now than the technical solutions. We can achieve incredible things if you give resources to engineers, but if you give them to engineers without a purpose, they'll use them and produce nothing useful. How do you guide that in the right way? And often when we don't know what the solutions are, we need to experiment a lot, of course, and try lots of different things, but you have to set objectives and goals and then provide resources towards that. So to me, that is the most important thing. Have we figured out what we want? Have we figured out how we're going to put the resources towards it? And then unleash a technical solution that, or different groups to develop technical solutions that can solve it in different ways.
Maybe a follow-up question. So in your experiences at your current company, but also at previous company, we actually worked at the same company, but at different times. Have you seen the culture around responsibility in space activities change among engineers, among managing people, among C-suite?
There's definitely an awareness. There's an awareness of what's happening in space and some of the issues that are creating problems. But the ability to respond comes down again to resources. If you're being driven to achieve certain technical outcomes because that's what the company needs to survive, then that's what you end up developing. Sometimes you have the latitude to think about what you're doing at the engineering level, but typically engineers are responding to the incentives they have, and those incentives are driven by the business leaders to serve the business purpose. And unless that business purpose includes a serious investment in responsibility, and we hear eSpace, part of that business goal has been set as treat the environment well. You've got to set that at a high level in the business. Otherwise, uncoordinated efforts by engineers will create some results, and they may create positive results, but they won't create coordinated results. And space debris is a bigger problem than a few engineers can solve in their garage, right? It's going to take a more coordinated effort. So it has to be set at the highest level. The resources have to be available for it. An awareness by the engineers is not enough. A political will and business willingness, a business rationale for it, that is what's needed to make results.
So Amy, you've been heavily involved in consulting in Washington, and you've also been at Viasat and multiple large endeavors, I would say. So do you see this awareness growing? Do you see the culture that we need? Have you seen the culture that we need, and how do you see this thing develop?
Yeah, so it definitely is growing. We saw this at the ITU. We see it in UNOOSA, COPIOS, all the discussions that we're having. Certainly this discussion, again, thank you to the SSA and CST and the ITU for partnering, for convening this. But I do think that there needs to be, as Claire was pointing out, a little bit of a cultural change, right? I think, often, as Dan says, to some degree, we go out, engineers, we break things, we, look to, trial and error and see what comes out. A little harder in space, a little more difficult because you are going to create an environment in the first instance that could be a huge problem. So I think there is drilling down and a slow cultural change that's happening to understand that we need to develop these policies, procedures, and indeed just the will to design in a way with fewer resources needed to actually achieve the goal. So can we design things that are not necessarily 2-ton satellites that we're going to put in LEO orbit? Maybe it's a smaller satellite. Maybe we don't need as many resources. Maybe it can do the same thing. I mean, you know, my phone, as they say, right, has about 100,000 times the compute power that we have than we had on the Apollo 11. So can we do a little bit more with less? So there's a bunch of ways that we can tackle this. I think that the climate, both on a policy side and the industry side, is changing. I think more globally, it needs to change on every level, from, you know, kids in you know, school throughout, you know, the industry and beyond. But it's going to take some time, but I think we have a good start going.
Candice, what is your perspective on this? Because if I think about it, you, by serving on the boards that you serve in and being stakeholder in several endeavors, you probably indirectly own the most amount of space assets in the room. So do you see that this this ethical problem around, or this cultural problem, we can sort of call it both, around space debris is being considered enough in decision making in these boards?
Well, so first of all, and this is a fun, you know, fact, but actually, and all of the women in the room, you know, will appreciate this, that the best way to get on a board is to create a company. Because, you know, it's pretty hard to say no to the entrepreneur who wants to be on the board. And very often, I was the only woman on the board for a long time on all of my companies. But, you know, every single time I started a new company, I started a new satellite venture, I started a new launch venture, it was always to do something and to provide something that was either righting a wrong. And so, for instance, I considered that, you know, the fact that monopoly broadcaster stations were telling people how to think, as opposed to being able to have freedom of choice. That's why I started, you know, SES. You know, with L'Oréal Teleport Europe, it wasn't allowed to have pan-European networks. You know, you had to buy half of a landline from the German PNT and half of a landline from the French PNT if you wanted to go from Berlin to Paris. And so, of course, by creating a satellite, you know, business VSAT network, we just went through all of the barriers. So I always, and now in doing so, I usually broke monopolies. And so I got this reputation of being a monopoly breaker. But I never, ever broke monopolies for that to be the end purpose. And so as Amy was saying, you know, I had a higher goal. My goal was to produce and, you know, and to deliver something that was better. And so, you know, everything, and I spoke yesterday about the fact that I do have this sense of personal responsibility, and I've just spoken about it now. So when I saw that people, and perhaps, you know, even me, because I am one of the, you know, the first team members of Iridium, which is really the precursor of the Starlinks and the OneWebs, you know, and Kuipers, etc. When I started to realize that if we were not careful, we were doing a tremendous wrong to the emerging spacefaring nations and to the citizens of those nations. And so, Kelly, when you talked about the fact that you were worried that these new spacefaring emerging nations might want to, you know, might not want to have sustainability, my fear is the other way around. My fear is that we, the longer spacefaring nations, will have taken away the possibilities and the opportunity for them to use their rightful claim to space for the orbital positions, the frequency bands, etc. So I really do call this a colonization of space, and I wrote about this at the G20 in Indonesia. And my brother, my big brother, who always had to protect me from the bullies, in school, he said, "Oh no, Candace, are you going to put Elon Musk on your back now too?" Because he's always had to protect me, or felt that he had to protect me, which was very sweet. But I really am worried about this colonization of space, and this is probably the biggest ethical question, that we have. And so here again, though, you don't just say, "Oh my God, there's going to be colonization of space." No, damn it, you fight against it, and you find a solution. And so that's why I also thought and I kind of do what, I tell everybody, transformational deals. And I really do think that this idea of this Space Management Association of assets, resource, and traffic that I talked about yesterday is a good way to get started. And I am working on that right now because we have to do something.
I have to jump on the colonization of space agenda.
Maybe Claire, you can give some background on how you would, how you think about the colonization of space, of course, but also about how you would advise boards to think about these issues a bit more in a broader sense.
First of all, I just have to say thank you, the elephant in the room, because for developing the global South, Africa, the Caribbean, many Asian countries, one of the impetus for me to kind of jump feet first into space, coming out of sustainability and industrial engineering and development planning in Washington, D.C., was this notion that if one company can have, basically suck up all of the orbit space and all the spectrum, when it's no longer that expensive for people to do it, and certainly many countries in Africa have the money to do their own satellite, how fair would that be? So the ethics of it is that space is the global common. And I understand that there's a lot of lawyers who say, well, the tragedy of the commons and we won't take care of it. And this is why we have to spend the time looking at space, recognizing it's just not something that is meant to be commerce. First of all, there is the awe and wonder of the fact that there is a cosmic presence that we all look out of from a faith perspective. People in the faith community see celestial bodies as holy and sacred. That's one thing we sometimes forget. Secondly, I once heard somebody in a futures conference said, the moon is just up there doing nothing. We should go and get all the minerals and so we can power our phones. I was like, the moon is up there doing nothing. Don't you understand? We'll be toast or roast if there's no moon. I mean, so if you have this mentality, this cowboy mentality, coming again 500 years after my forefathers would have been enslaved, Africa would have been colonized, we simply will not sit back and allow this history to repeat itself. And so those people who are in this room who feel the same way, like Candace here, those young people who are part of the SJC movement, the different space sustainability movements across the world, really get it, right? Whether they're in the US, they're in Europe, they're in Africa, they're in India, they're in Vietnam, they get it. We just have to find a way to bring us together in a different way. And so I'm happy to see that at the IAF, for example, and IAC, there's a concerted effort to bring these diverse voices into these conferences in Baku. And I understand it's going to be, I don't know where it's going to be this year, but there's an effort by many wise people that we do not need to repeat the sins of the past, right? Recognizing the Ubuntu, I am because you are. We're not going to get out of earth alive. And so I'm with you. I'll stand with you to fight against the Buccaneer bullies, right? And make sure that everybody has an opportunity to put their point of view on the table, and hopefully we can avoid, a Star Wars for real. right?
Yes. Well, that's fascinating because I do see a friction, you know, because we have people on the panel who are saying, okay, it's driven by commerce, you know, then it's saying this thing is driven by commerce. We have Candace saying that she wants to have a space economy, you know, really.
No. Well, I have always tried to, yesterday and today, and make it very clear. And, you know, a lot of people laughed at me, but that's okay. You know, my mother always told me it doesn't matter, you know, if people laugh at you. No, purpose-driven, responsible actions and doing. It's not, you know, and you know, that's the whole point. If you do this, it is triple bottom line. It is profit, you know, planet people. It is. And it really is. If you do the right thing, and, you know, I have to believe this because I've believed it all my life, you will succeed.
What I really appreciate, Candace, is you started these companies with purpose.
Yes.
And you put a business model around them and made it work.
Yes.
And that is a great way to create change.
Yes.
I talked about the needing the economic, like the business motive, needing the political will. They come, like, why do you start something? Why do you put a business together? Why do you try and create that support, the cultural support for the political will? Candace has embodied that and been able to make that change. We need to look at space debris in the same way. The companies that are doing active debris removal, space situational awareness, everything that's been talked about today, these are companies founded by people that believe we need to fix this problem and believe that it's a significant problem. It's baked into the e-space model, right? How do we do this sustainably? How do you put a business model around that and then make it happen? To me, that's the exciting thing and the challenge. How do we take this passion that Claire has and turn that into a model that we can execute that's going to make business sense and or political sense, right? These are two things that can motivate us.
I could add, I'm sorry.
Yeah, go ahead.
If I could just add, because I do think there were a lot of things talked about over these last 2 days that if they really do come together with all the modeling, with all of the technology, as far as, you know, what you're creating, Dan, and the idea around access to space for these, you know, new spacefaring nations, you know, all the countries in Africa. I mean, the amount of, by the way, space agencies that are being created over the globe are pretty impressive. And everybody has an interest in, you know, some of it is a sovereign interest, you know, because they want to, you know, figure out how they can capitalize on space in many ways. But you know, maybe it's systems of systems. Maybe it's, you know, this collaboration, getting together, making sure that we have enough space in space to do what we want. But I do think that, you know, whether it's automation, whether, you know, AI, ML, all of these things, I think we are going to be able to have that space in space. Maybe it's 2050 or whatever you know, you're looking at. But
if we dream a bit, so if we look in 30 years, so it's 2054, and space debris is a solved issue. So we think about it another way around. We don't think, how do we solve the issue? We think it is a solved issue. That's the baseline. How does the space system look? How does the space industry look? Can you share your views?
So it depends what you are considering space. I mean, so are we talking about just around our Earth? Are we talking about other planets? Are we talking about other exploration? I mean, I think, you know, we've always looked, you know, we're explorers. We go out and we look for new things to conquer. What I actually see is that, you know, we will have challenges of maintaining that existence, right? Whether it's a geopolitical situation or not. I also think that there is an ability to harness that peaceful use and create more things that can benefit us on Earth. So that's what I would like to see, is that we actually are able to do these things that was talked about in the previous keynote, all the experiments happening, you know, on Axiom or other space stations, making sure that we maximize what's going on in space for the very people that are actually creating some of these systems and beyond for the future.
Mm-hmm. Dan, what's your view for 2054? What are we going to talk about?
I look forward to the time in somewhere between 50 and 100 years from now when the economy in space is bigger than the economy on Earth. all the things that we're doing now, building the infrastructure, a better access to space, more activities in space, cleaning up space and making sure that it doesn't slow us down from creating that in-space economy. That's important work that we're doing. You wanted examples of how we might solve this problem, though. Not enough people laughed at my idea or liked my idea of tungsten balls in retrograde
It's pretty
orbits.
funny. I think it's pretty funny.
Okay, I'll give you another one, and this one is meant to be more thought-provoking. People may not be familiar with the idea of the Enclosure Act in England. Around 1600 or so in England, there was a lot of land held in commons, and anybody could go and run their sheep on it or pick whatever food grew there or what have you. And the tragedy of the commons comes from a description of that where it's over-farmed and utilized, and it wasn't improved. It generally wasn't the most productive land. They decided they would enclose them. And political reasons for the benefit of a few, etc., like perhaps not things that we would necessarily look on favorably, but they fenced in the land and they said, great, now you landowner, you own this land. The result from the use of the land perspective was a massive increase in productivity. Food output in England doubled over 100 years. That allowed the population in England to double. The land was improved, it was drained, they had proper crop rotation, it was managed because somebody owned it and they could invest in it and get those rewards. So in one respect, very much more efficient use. The other side, it pushed a lot of people off the land, coincided with an industrial revolution, and there was a supply of labor. Whether this is good or bad depended on exactly where you sit and how you and your people got through that period. But if we want to solve space debris, my proposal is that we enclose it, we privatize it. Let's give a nice sliver around 500 kilometers to SpaceX, and everybody should have their 10-kilometer bands. And if satellites pass through your band or decide to go into orbit there, you get to charge them a fee. But if nobody likes your orbit because it's full of debris, nobody is going to park there, and they're going to move somewhere else and pay somebody else a fee. And your incentive is to keep your orbit clean, because you want people to come and use your orbit. Maybe this is a profit motive that causes people to keep the orbit clean, to make sure that it's well tracked, to hire a debris removal company. What does it take to make sure that I can earn some money from what is now my property? So there's my crazy idea for the day for people to think about. Let's privatize different bands of altitude in space.
Claire, do you think that sounds like colonization?
Well, my 2054 dream is that we are going to be on our 4th outing of the Space Goodwill Games, and the Live from Lunarville show will be aired from the Human Lunar Heritage Site on the Moon, and I will have my dream of my Space Goodwill Games, my Chapel of All Religions on the Moon, and my Human Heritage, Lunar Heritage holodeck, where we play out stories and space tourists come up and enjoy that. Obviously, this is all possible because we have solved the problem of space debris, and so we can get there safely back and forth as humans. Finally, I do also agree that by then, we will have done this because all other things have happened. We have gotten space solar power operational. We have gotten magnetic electric propulsion going. The people who are tinkering have succeeded at that. We have been able to begin, because my pet project, the Space Futures Collaboratory, was started as a result of this conference, and we're beginning to play those games and do those scenarios and have that cross-fertilization of ideas across sectors and cultures and all the things that make us different and destructive as humans, to find the safe course forward. And then perhaps then we'll have this river that we can all have a piece of, and it won't be owned by one person, but we'll have collective ownership, because we'll have trained ourselves to think that way through some of the games we have played. And so because everybody who has a smartphone or 2 or 3 gets a piece of the profit from keeping this orbit thing free and clear, then we have the will, the political will, and the emotional and mind and the spiritual mind field on which to build a safe, just space for humanity.
Candice, give us your thoughts.
Okay, so First of all, Daniel, I like your idea. I think that actually, and this was what was very interesting when I was speaking with my friend Del, who would have loved to have come here, but he has some mobility issues. And, being a lawyer and having been one of the first space lawyers, he still feels that the founding principles on which the ITU and the UNOOSA were created are still good. And that just kind of like the Magna Carta, you can interpret it a little bit, but so the only thing, because they do have, we have coordination of the bands and et cetera. So, we can interpret it a little bit differently. I think also, I'm sure that a lot of you know, very interesting that, King Charles, who was one of the first environmentalists and everybody laughed at him, has now created the Astra Carta, which I think is so interesting, also for the sustainability of space. Harold, when you talked about dreams, I don't like dreams, because dreams don't happen, but visions do. Visions do. And so I really am working on this networks for the universe. And for me, the networks for the universe means logistic networks, transportation networks. Claire, I'm very involved in the space-based solar power, which I really do. So energy networks, data storage networks, communication networks. How are we going to be able to communicate and stay in touch with the people who do go to Mars and other places? And so, we're talking about metaverse, we're talking about the digital twins, and certainly quantum will be playing a very, very important role, as well as, brain waves. People are a little bit worried about augmented brain technologies, but I honestly think that's probably, what we will need. So, but the only difference, I guess, is that I really do believe that everything that we do in space is, and I quote Frank Salzgeber on this, who 15 years told me ago, said, Candace, I think we all do it for Mothership Earth. And my dad, when he was at the White House with President Kennedy, he came to speak to my 5th grade class, and he told everybody, I was 10, 1962, and he said, one day we will have satellites for telecommunications, for education, for entertainment, and when we have wars, we will have wars in space, and we will have peace on Earth. So I hope that we will have peace on Earth. So thank you.
And peace in space, of course.
And peace in space as well.
Peace on space, too.
Yes, yeah.
So, are there some audience questions? I would like to open it up for 1 or 2 questions. Please make them a bit concise and to the point. They can be futuristic, but please with some, make it sensible. Come on, there must be one, at least.
Well, if they are not, I am hoping that we will get to hear from our wonderful leaders at the Saudi Space Agency. I guess we'll have a closing ceremony. I think I speak on behalf of all of us who are speakers, participants, attendees. This has truly been a unique experience these last 2 days. It has been imbued by the warmth, the intellectual, really curiosity, and the rigidness to truth. And it is, conferences like these that really will change the world and the universe. So thank you all so much.
So maybe let's do a little round. So Amy, if we reunite in 2 years, what are we going to talk about? What progress should we have made, at least?
Well, I think certainly solving the interest by policymakers, interest by those who might fund some of these solutions in the near term. I'd like to see coming out of this actually some action items, right? Action directives where we can come back and look at those metrics and see how we did. You know, I think it's imperative that all of us actually continue to have these conversations, continue to actually work on the designs, work on the investment to make it happen. So I'd like to see some actual action on some of these initiatives, and maybe there's a collective, you know, work that comes out of this that we can work with the Saudi Space Agency to see, you know, what comes to fruition.
And which specific initiative would you be really keen to be progressing on?
So honestly, I think it's sharing of data, to be honest. I mean, I think if you're looking at actually working within the current environment, you know, these modeling techniques and working with, you know, whether it's Leo Labs or Clear, you know, some of these other companies that have all these different models, like we have weather models, I think there needs to be some sort of collective wisdom so that we can actually operate in space in this artificial intelligence world, or, you know, automated servicing world, where we can actually coexist. We can know predictively what's going to happen over time and really not have to worry about it, right? Yeah. So that's what I'd like to see.
And Dan, where would you like to be in 2 years? Here, of course, here in Saudi, Riyadh, inshallah.
I think it's absolutely right. We need to get onto action. But we're at a really interesting time now. The debate around space debris started, I guess I started to hear about it about a decade ago. The conversation has now become mainstream. And there's also actions that are being taken. I think in 2 years, we're going to be talking about the results of a lot of the first activities. Right? A lot of the data should be shared about the space situational awareness. New systems should be online. We should have ground to space, but also space to space situational awareness, better mapping. We'll be talking about lowering the size of debris that is tracked. We'll talk about lowering the error ellipses. And that'll be interesting and statistically important. But also the active debris removal missions that are being funded around the world, they will have been tried, so we should be able to go from tracking debris and knowing where debris and satellites are, to reacting to that, to deorbiting pieces of debris, and being able to put that chain together, being able to think about business models around those and how we intend to pay for it, about the supply chains that support that, right? The Orbit Fab is building the gas stations in space. How do we bring the propellant that's needed to satellites so that they can get out of the way, so that they can deorbit other things, so that we can go to other orbits? How do we bring all that together? So after the demonstrations have happened, now we get to down select the things that have worked and start thinking about changes so that we can do the next generation of improvements. That's where I want to be in 2 years.
Claire.
Yes, so in 2 years, when we build on the actual, let's say, the technical happenings, we have the Space Futures Collaboratory going. We're doing the simulation modeling, we're doing the digital twins, we're doing the gamification. We're also amplifying the conversation, working with young people at the cutting edge. So I can imagine, for example, at a conference 2 years from now here, we'll be having, let's say, doctoral students who have been in a lab from different parts of the world crunching information, coming up with some potential scenarios that can be shared back to the policymakers to say, if not this, then what? So I think side by side, while the engineers are engineering, they quote unquote, the policy engineers, I call myself a policy engineer these days, or a sustainability engineer. I'm taking data which is technical as well as social and geopolitical and trying to run the roadmap side by side. Because we can't move in sequence, we've got to move in parallel. It's that urgent, and so 2 years from now, I would hope we have that action on a different level. And a conference like this would have not just a audience and speaker distance, but we'd also have a space, again, for that interactive force to happen before we come into the room and then hear from each other.
And it's,
well, you know what? We need to do a business plan.
Yeah.
And, you know, every single time an entrepreneur comes to me and I do Saturday morning mentoring sessions. Some of you have partaken in them. You know, I said, well, what's your business plan? And a lot of times, you know, people do business plans to get investors. And I say, no, the business plan is for you. It's a reality check. Can I really do this? What are the numbers? Who are the clients? What are the benefits, material and immaterial, et cetera? And I honestly do think that if we did do a business plan and we set our goals, we were able to say, these are the, you know, these are the material benefits, the immaterial benefits, the goodwill, et cetera, that will be generated, we will be able to solve this. I'm quite sure we will. So let's do our business plan.
I applaud that as well. So thank you very much. I think we had a very interesting, wide-ranging discussion, even about spirituality, ethics, and the future. I think we'll have some closing remarks, and then we can wrap it up. I think it was a really nice conference. Thank you very much for coming, everybody. I hope you enjoyed Riyadh. I hope you enjoyed Saudi Arabia. And we'll be happy to see you back, inshallah, 1-2 years.
Thanks for having us. Thank you, Harold.
Talking about keeping best for last. Thank you, dear panelists and our dear moderator, for this lovely panel. Now, before we end our day, I would like to call on stage the Deputy CEO at SSA, Dr. Val Monsami, for some closing remarks.
Thank you, Fatima, for that. I want to share a very sort of personal story as I close. So my wife and I worked in a ministry where we were setting up the space agency. This was in the late 2000s. And she normally follows all the conferences I go to online, so this one as well. And last night after the dinner, I got home at 11 and she was awake. And she was extremely excited. She says, this is the best conference that I've seen online. The caliber and the quality of the conversation was amazing. I understood it. And she started to ask me questions. So who's going to pay for this? How are we going to clean it up? And for me, that was just a testament in terms of the caliber of this conference that we've had over the last 2 days. So we started to, in this conference, ignite the conversation. But it's just as I said yesterday, it's an inaugural conference. We will come back here in 2026. But I think it's just about sparking the thought process in terms of what's possible. And I truly believe that we are at a juncture right now. If you look at the mega constellations that are coming online, we've got the space debris issue. And if we continue on the status quo, it's going to exacerbate itself. So we've got to do something concrete, and it has to be done right now. And I think what we've discussed over the last 2 days was to put the ideas and some of the potential solutions on the table. And I'm glad that from the Saudi Space Agency perspective that we've, and I know His Excellency gave us 60 days, but we counted 40 days, a challenge to put this together, but we did it. And it was testament to the team that is working in the background in terms of the long hours that we pulled to get this done. So I salute the team for that. But I really want to extend our sincere appreciation to the international experts that have traveled far and wide to actually be here. It shows your commitment to this current issue that we are facing. And you know, as you go back, we want to ensure that we maintain the linkages and the conversations and the collaboration going forward. So this is, as I said, this is igniting a conversation, but it's not just a conversation. It's a pathway to concrete action. And we want to see a roadmap emerging from this conversation that 2 years from now, 2026 Q1, we will come back and have a very different conversation. We would have leveraged the strength of our collaboration, our partnerships, and the spirit of trying to do something based on our consciousness and our values system in terms of what we want to achieve going forward as humanity, but also ensuring that we clear the space for that to achieve. So thank you for attending the conference, and I think from my perspective, it was really an honor, together with His Excellency, hosting all of you. We've had a great time, good conversation, and we really want to see you back here in 2026. Thank you, and travel safely.
Dear ladies and gentlemen, we have come to the end of our second and final day of the Space Debris Conference. It was such great and illuminating 2 days. And on behalf of His Excellency, Ahmed Al-Tamimi, I would like to pass our heartfelt thanks to our amazing speakers, guests, experts, and students who joined us today and yesterday, and all those who joined us virtually as well. It was absolutely thrilling to have you all, and we look forward to seeing you in the near future as the conversation continues. Have a lovely evening.